To get access to the Network Plus notes as well as the mock exams and the practice question slides, join the Hackaholics Anonymous community. If you join as a cyber agent, cyber guardian, or cyber master, you'll get access to all of the notes, the mock exams, and practice question slides, as well as many other perks that are available to Hackaholics Anonymous members like Python automations and exclusive content, as well as monthly live streams with me. And to join, you can click the link in the description below, or you can go to our homepage and click the join button there, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now let's get back to the Network Plus training. Now at the top of our network operations section, or our network operations chapter, is the organizational processes. And organizational processes are the processes that literally, as the name implies, it's for the organization of the network itself and the processes of those networks. I feel like a lot of these things, the label just kind of gives you the description. So they ensure that the networks are effectively managed, documented, and maintained for reliability, scalability, and compliance. So that would be like the best official description that we can give it. Documentation, specifically, change management and configuration management are the key roles, or they play those key roles in maintaining a well-structured network. Now, documentation has several elements to it. So it actually holds the network's design in it. It helps with the operation outline and the policy breakdowns, the policies that people have to follow, the policies and regulations and frameworks that people should be abiding by, the design elements of the network, so the actual network diagram, for example, and we'll look at a pretty good one in just a couple of seconds. So the documentation element ensures that there's continuity. It's simplifies troubleshooting and facilitates onboarding. So you literally have training manuals that fall under documentation. You have onboarding, new orientation, or new employee orientation that would fall under documentation. The continuity portion of it is that, like, when somebody passes on their responsibilities to a new person, as the person A gets promoted, person B is also getting promoted from a lower role, and they're coming to fill person A's previous role. So it ensures continuity so that the new person that's stepping in does the activities and takes care of the responsibilities of that role in the same manner, and they just literally pick up where the other person left off. And then simplifying troubleshooting is kind of a easy thing to understand. There's breakdowns of what you should do in case XYZ happens, and you just go and do you take these 3 steps or 5 steps or whatever it is. You contact this person. This is the contact list that we have. This is the resource list. These are our vendors. If you need to replace something, if you need to fix something, this is the person that we call, So all of these things fall under documentation. And the better that the documentation is inside of a company, the better things actually flow and they get managed, because everything has actually been broken down. Everything has actually been explained for people to just read and follow. And really, I feel like that would be the biggest favor that you can do to your employees, to just make sure that they have really detailed outlines of what they should be doing, and have a big binder if you want to do it that way, or you can have a searchable document that is digital, that they can literally run Control F or Command F and search through the document to find the name of whatever it is that they're trying to solve, or the steps that they're trying to take, etc. So the first part of this, the first key type of documentation, is the network diagram. And this is the visual representation of the network's structure. And it includes devices, it includes connections, it includes logical groupings. And we'll be creating some network diagrams as well. But I mean, for the most part, you can just Google on Google Images network diagrams, and you'll see, thousands of them, literally. There are physical diagrams that show the actual device placements and cabling, and then there are logical diagrams that they depict the IP addressing, so the various subnets, for example, the gateways, the virtual LANs, the segments of the network, right, the broken down of the different segments of the network, and the routing protocols, as well as the the actual routers themselves and where traffic will be routed between the various segments of the network. And the tools that we have for creating network diagrams are some really good ones. So Microsoft Visio, Lucidchart, SolarWinds Network Topology Manager. There's a lot of other ones as well. These are kind of like the big names that are in this category, but you can find a lot of them, and a lot of them also offer free tiers, and then there are some that are just straight up open source. So there's a lot of different tools that can be used to create network diagrams, and they're also very useful and highly recommended for you to practice with and use just to get the flow down and get a good understanding of how to read network diagrams as well as how to create network diagrams. So the use case for this would be if you're trying to troubleshoot connectivity issues by reviewing how devices are actually interconnected. And if you see that, let's say router A3 is down or something, when you're looking at your monitoring reports, you look at your network diagram and you're like, oh, router A3 is connected to this VLAN and so on and so forth. So once we see the visual element of this, once we actually see the network diagram, it's literally in the next slide. Once we look at it, you'll be like, oh, okay, I totally understand how this actually can be helpful. And this is it. So if I zoom in any more than this, these things just become very foggy, and it's kind of already hard to read. So I do apologize for that. But we can kind of break it down from the logos or these individual images. So the actual data coming in from the internet or the cloud or wherever it's coming in from, or let's say that these are just connected to each other. So this would be an internal network diagram specifically. You have the routers that are connected to it. You have so you have a router over here that has a firewall. You have a router over here that has a firewall. There's the internet that exists over here. So this is actually, this cloud represents the public internet. And then we have a router that is connecting to this specific device. And I can't read the logo of that, so I don't know exactly what this device is. It could just be the domain controller, or maybe like the server controller. The router controller could be potentially it, because this is the single device that is connected to this router that is going from the internet in and out. And then we have, from this internet cloud, we have the firewall that the traffic goes through before it gets to these routers, and then these routers actually enter these segments of the network. So we have this router pointing to these three switches that we have right here, and then these three switches. So the central switch right here connects to these devices that we have right here. These are three VoIP phones that we have, and then these are some desktops that we have connected over here. And then this one comes through the central office and connects to the it says the telephone network. And then from the telephone network, this also gets connected through here as well. And so we have some media servers that are now fed from this router that also get connected to these switches that will also get connected to this network right here. So this network should be able to access these media servers, as well as, of course, this network being able to access these media servers. So this specific network, this specific segment of the network seems to be just an office. So it has these three different phones, these landlines that are running from VoIP because they're connected via the internet. And then we have these desktops. And then from here, this segment of the network is connected to this segment. And this seems to be both for data processing or media access, data storage kind of a thing, as well as another office. So we have another smaller office over here that only has two phones, and it still has four computers. And then we have these media servers that would store media. And then we have these servers at the bottom right here. One of them is the email management. The other one, I think, is a, what is that, CTI server? I feel like I can't read. The email management one is a little bit easier because there's an actual email, like an envelope over here. There's an infrastructure response, and then we have the server as well, this like main server over here that I think is the server that's used to manage these four servers that are at the bottom right here. But essentially, as we look at this, you can see, assuming that you could read all of these things and it would be a little bit clearer, you could see how easily you can get a one-shot view of the entire network. Now, this is not a complicated network, even though it may kind of seem like it is. This is really not that. We could say that it has three main segments, and you have this is one, you have this is one right here, and then you have this big piece is another one. Technically, we could say we have three main segments. We could actually even break this down. So this could be one segment, this could be another segment, this could be one segment. These media servers could be one segment right here. So this would be one, this would be two, this would be three. We have this thing that could, I guess, act as its own. So that could be four. And then this piece right here could be five. And then these switches are essentially acting as connections between this segment and these segments. So they could technically act as their own segments, but all in all, we could safely, comfortably say that we technically have five various segments inside of this network, and it's not really that big of a network. So imagine if this was 2x or 3x or 5x the size that we see inside of this diagram. And if this is 5 segments that we have over here, then you're looking at 25 segments, something like that, right? And those 25 segments would have, let's say, 5 main branches, and then inside of those 5 branches, you would have 5 other subnetworks. So it can get large very quickly. And the main purpose of this is that, especially if you're using a really solid network diagram software, is that you could just zoom in to these various areas and you should be able to see. I mean, this kind of is easy to see that this is a media server, IP phone. I can't see what's under these things right here. CTI server, email management, interactive response, ACCM server. We can kind of see that. So with the various softwares that I mentioned earlier, when you actually zoom into these segments, and then you can click on any of the devices and their logos, and then from those clicking, you can actually see all of the details of the devices and the list of what they're actually connected to. So if we zoomed in on this one and then clicked on this switch, we would be able to see these list of devices that are connected to this switch, and then we would be able to see the IP addresses that are assigned to these devices, and so on and so forth. So the actual network diagram software is very useful when we create these various designs, because not only does it show you the visual, like the one-shot visual of the entire network, but it also, if you wanted to see a list of the IP addresses that belong to each one of these subnets, you could see it, or in each one of these segments, you could see it. So they're very, very useful. They're very, very useful software. And we will definitely mess around with some of them as we go into the practical portion of this training series. So you'll get a chance to actually see me use them, and then I will highly recommend that you download them and use them yourself so that you can get the hands-on experience for yourself as well. So let us now move on to the next piece. The next few pieces under documentation would be IP address management and the service level agreements. IP address management would be the centralized management of all of the IP address allocations and usages. And so you would have, of course, the lists of the subnets that are here as well, the DHCP scopes, and scope in this particular case covers the list of the devices and their individual IP addresses that belong to these various subnets. It tracks the IPv4 and IPv6 addresses that have been assigned to the various devices. It prevents IP conflicts and inefficient allocation. And we did talk about the breakdown of the IP addresses that are available inside of any given subnet, and how you can create a subnet to only take up, let's say, 28 bits for the network, so that it leaves you 4 bits, and then 2 to the power of 4 would be the number of IP addresses that would be assigned to that individual subnet, so on. So we talked about this earlier in the training series. So these are just a couple of the features that are available under IP address management. Now, if you have a company that has, let's say, 5,000 employees and 2,500 devices or something like that, this is going to be a big list. So the IP address management, IPAM or EPAM, whatever we want to call it, this is going to be a very long list of IP addresses, and it's obviously going to be hopefully organized to the various subnets and the different departments and their ranges and so on and so forth, these scopes, so to speak. All of those things should be organized so that you're not just looking at one long list on a freaking spreadsheet or something like that. Hopefully it'll be more organized, but this is basically just the part of documentation that tracks all of the devices and all of the IP addresses that exist within a given network. Now, instead of using a Google Sheet document or Microsoft Excel or something, you can actually be using these things. So it's the Infoblox, BlueCat, or the SolarWinds IPAM. And so SolarWinds is one of those names that is pretty all-inclusive. Like, they have many subsegments or subcategories to the software solutions that they provide, and those software solutions can fall under network monitoring, it can fall under security, it can fall under organization of documents, as you're seeing right here. And so it could be the SolarWinds address management, the IP address management, that could be an element of it. We saw SolarWinds in the last little section under the network diagrams as well. So SolarWinds is one of those really big names, but for the most part, it does require some kind of a commercial license to be able to access it because it is a really big name. They also are used by very many companies and government agencies, and they got hacked at a certain point in one of their updates. The update's source code had some really pretty crazy Trojans that were embedded into it, and as a list of their clients, like a large list of their clients, as those clients upgraded their SolarWinds software, that injection, that Trojan that was injected into the source code was distributed to all of those clients. So it was a really big scandal. And the story is covered a little bit more in depth inside of the Security Plus training series. So if you actually go find the Security Plus playlist on this channel, it's one of the examples. At the end of each section, I give like real world examples of what happened for a given topic or concept or something like that. And we go through a lot of different hacks and a lot of different attacks that had happened against massive companies, and Target and SolarWinds and Microsoft and Facebook and all these different people. So SolarWinds is just one of those really big names. Now, obviously, they patched it and they fixed their software, and everything has been mitigated by now. But at the time, it was a really big deal, and it falls under the supply chain hack kind of a thing, where it's like, if you're a company that uses SolarWinds, and I do realize that I'm kind of going down the security rabbit hole. I just can't help myself because I'm a nerd when it comes down to security. But that falls under supply chain. So if you're a company, let's say you are, I don't know, let's say Microsoft, right? So let's say you're Microsoft and you're using SolarWinds as your supplier for a certain set of software, and something happens to SolarWinds, like somebody hacks SolarWinds, now Microsoft is vulnerable. And by using SolarWinds, Microsoft can be exploited, because if the exploit is strong enough and it's malicious enough, it can go from the SolarWinds software and it can actually penetrate the Microsoft network, and now Microsoft is hugely at risk. So supply chain security is actually a really big deal. And this is actually the piece that we're going to be talking about over here. So, because service level agreements are the agreements defining the level of service a provider will deliver to a client, and this falls under the supply chain as well. But one last note under the IPAM is that the use case is to, for example, to assign IP addresses for new devices in a growing network. That's basically what IP address management is. It's more than just a list that stores the IP addresses of the devices. It's actually something, especially if you use a specific software, for example, SolarWinds IPAM, if you use that software and you have integrated it with the network monitoring and a variety of other solutions that they actually provide, now you can assign IP addresses for new devices in your network, as well as manage them, as well as add those devices to your network diagram, and so on. So now service level agreements, the SLAs, are formal agreements that define the level of a service that a provider will deliver to a client. So the client could be Microsoft, the provider could be SolarWinds, the client could be the United States Treasury, and the provider could be SolarWinds, right? So there are different layers to it, but essentially it's basically there's a client and a provider relationship. And a service level agreement, technically, if we wanted to look at it, is, when I purchase internet service from Spectrum or AT&T or whoever, there is going to be a service level agreement that I'm going to agree to, that I'm going to say, hey, listen, I'm going to promise that I'm going to pay you my bill every single month, as long as you promise to provide me service and, of course, give me secure service and don't sell my information to anybody without my permission, and so on and so forth, right? So service level agreements are basically contracts that two parties have, and it could be something that also involves a dozen parties. So it doesn't necessarily need to be between just two entities. But at the very basic level, it's at least two entities. There's a client and there's a provider or a vendor or a manufacturer. And this all falls under the service level agreement. Now, the key components of these service level agreements for the context of networking is the guarantees of uptime, right? So for example, 99.9% uptime. So if AT&T comes and tells me that if you buy service from us, if you buy your internet from us, then we will guarantee you a 99.9% uptime, which means that 0.1% of the time there may be some kind of an outage in your area, right? But for the apart from that, we will guarantee our uptime. And here's how we're going to guarantee the uptime. We have what is it? Towers here. We have like cell towers here. We have the most number of cell towers across the United States, or some crazy whatever. Like there was like a big portion where Verizon and AT&T were constantly competing with each other, and he was like, "Here's our service coverage map, and we have the better map, or we have better service availability in these areas than Verizon and T-Mobile do, or whatever." So this all falls under the service level agreement, and part of that is the uptime guarantee. The other part is the response and resolution times for incidents, especially if you're a business, right? So if you're a really large business and you're using freaking Spectrum or AT&T for your internet service, you have a big contract with them and you're writing them a really big check every single month. And if that's the case, you want to be insured. You want to rest assured that there's going to be, if I have some kind of a troubleshooting issue, or if I need some kind of response from you, if I need customer service from you, you're going to deliver to me, because I'm writing you a freaking check for, let's say, $1 million a month or some crazy, because honestly, it can get really expensive when you really think about it, right? If you have like 1,000 different locations and each one of those locations is paying $1,000 a month, you're literally writing $1 million check every single month, because just for my little home, we would pay anywhere from $50 to $100 for our internet service. So if it's for an office building, or if it's for like, not even an office building, just like a normal, let's say 10 unit building, nothing commercial, right? Nothing that has 50 floors or anything like that. You have like a 10 unit building, and each one of those units is paying $100 a month for internet. That's $1,000 for that location. And if you have 1,000 of those you are literally writing a check for $1 million every single month. So your company is responsible for paying Spectrum or AT&T $12 million a year. And so if I'm paying you $12 million a year, you better freaking respond to me. Like, you understand what I'm saying? And if you don't, I'm just going to switch my internet service and I'm going to go with your competitor, and now I'm going to write them $12 million. I don't care how inconvenient it's going to be for me to set up the new service or whatever, because they're going to send their people and they're going to set it up for me, and we're going to make sure that we have the new service before we cancel your service, and there is never going to be a lapse in our connectivity, and you just lost a $12 million a year client. So you understand what I'm saying? It's very important. It's a part of the service level agreement for them to provide response and customer service and resolution and all that. And then, of course, performance metrics, right? So the latency and throughput. Latency and throughput would be the speed and the availability of the service that goes through the various sub networks inside of a location. So performance metrics So giving you the analytics basically of the performance of their service to you. And this could be something, again, so I'm using an internet service provider as an example, but it could be SolarWinds that's giving you their service level agreement, and they're saying, our software isn't going to crash. We're going to have regular maintenance. Our servers are going to be up all the time. If you have any kind of customer service requirements, let us know, and we will be obviously sending you there's like various dashboards that you can access that you can get your analytics and your metrics for the various solutions that you're purchasing from us. So a company would evaluate the terms of their SLA to ensure that their chosen ISP, internet service provider, meets their performance requirements, and that would be just one example of this. Service level agreements are essentially for any major service, that as long as it's not like some kind of a back alley agreement and even those back alley agreements, there's at least some kind of a handshake deal where there's expectations from both parties. So even in those environments, you will have some kind of a service level agreement. But for most services, like the grand majority of services that we would be purchasing from any kind of company, there is some kind of an SLA where we're saying, listen, I'm going to pay you and I'm going to be a good client to you, but I need to make sure that you are going to provide everything that I need, and the terms under which you're going to provide your services are agreeable to me. And all of this is outlined in the SLA. So this all falls under documentation. Now moving on to change and configuration management. So this is when any changes or configurations are done inside of the network, and this all falls under operations still, obviously. So these processes govern how changes are planned, how changes are implemented and tracked within a network to minimize risks and disruptions. So this is technically also falling under another major category of documentation, but this is under operations technically. So there are changes that are going to be made. And when you do make changes, for example, if you want to change your internet service provider, so you got to plan the change, and you got to say, we have all these locations, and you got to talk to your new vendor, and you got to make sure that they're all good and they understand what they need to do, and then schedule everything. And then the day comes that now those changes need to be implemented, and now you have a dozen different locations that need to be getting under the new service. So we need to track the process of, or the progress of all of those things to make sure that everything goes over smoothly and there are no risks or disruptions, or at the very least you have minimized your risks and or potential disruptions. So a few key concepts under the change configuration management. Number one is change management. So there are steps to this, obviously. So first you make a request for the change, and you propose this and document the change request. And this would be the request, for example, that you would first make to your company's C-suite executives or your main decision makers, saying, hey, we believe that we need to change this part of our operations for whatever reasons. Now, once you've made that request for the change, that request first needs to be reviewed and approved. And this is done by higher ups, as well as, any other subject matter experts or stakeholders or anything like that. They would evaluate risks, impacts, feasibility, and feasibility obviously covers the budget as well. So it's like, okay, well, is this going to actually cost us more money? Or if it costs less money, usually that's always like a really good thing. But if it costs you more money, now it's like, okay, well, why are we doing this? What exactly is the purpose of this? Can you justify the increase in the budget? And then once it's been approved, then you actually put a plan together to implement it. And it details all of the steps, any rollback procedures that are going to be involved, and then scheduling out all of the changes that are going to be made and giving them a timeline that, okay, we expect that this will be done in the next 3 months across all of our different locations. And once those changes are made, now you got to test and actually make sure that the changes are actually working. So you do this in a staging environment, or a sandbox environment is another way to say it, before you actually apply it to the production, meaning to the rest of the company. So the first step in this would be, okay, so as far as the implementation plan is concerned, the first thing that we're going to do is we're just going to apply it to one location first. And then we're going to verify those changes. We're going to make sure it works perfectly in that one location. And then if it's all good, then we will go ahead and apply it to the rest of our company. If you have offices in every single one of the 50 states in the United States, I would say, okay, we'll test it on the East Coast first, then we'll test it on the West Coast, and then we'll test something on the Central or the Mountain Coast or whatever it is. Once we have at least tested it in the 3 different regions, then we'll be like, all right, so now we can apply this to the rest of our 50 locations or the rest of the locations in the 50 states or something. And then that's what it means to actually go into production and send it to the rest of your business, your locations, your network. Then you have the post-implementation review, which basically you just need to know, make sure that all of these changes that you made, especially if you spent extra money, you want to make sure, okay, all right, so is this actually working as we thought it was going to work? Was it worth it? And so on and so forth. Because if you have a really large company and you're making big changes across your entire company, it's a pain in the ass to go through this process and get everything done. So you want to make sure that everything is working as expected, because if you needed to revert back to your previous service provider and just go back, it's going to be another whole freaking process, and it's going to take another 6 months or whatever the first length of time was that it took. So it's a big deal. It's a big deal, and it's a big process to manage the changes made to the infrastructure of a company or to the service providers and a lot of stuff. So a use case example would be the upgrading of the network firmware while ensuring minimal disruption. Now, firmware thankfully falls under a category of software. So we're not talking about replacing physical infrastructure, which would be insane to think about. So you're just updating the firmware of the network, which falls under software, which technically means it should be fairly easy to test it in one of your sub-segments as the staging environment and make sure that it all works great. And then you test it in a building that you have. So that building has, let's say, 5 segments, and then that all of that worked great. All right, great. Now we can expand it to the rest of our locations in the company. The next piece would be the configuration management. So this tracks and manages network configurations to ensure consistency and compliance. Let's not forget about compliance. So the features of this would be, centralized repository of configuration files, the automated backups for quick recovery after failures or any kind of service interruption, version control to track changes and prevent unauthorized modifications, and using checksums and hashing is probably a really big piece of this, because we're talking about network configurations and digital changes, and a lot of these things aren't based on the physical infrastructure. Again, this is all digital infrastructure. So if you are using configuration files, for example, each one of your configuration files has a checksum. It has a hash value, and those hash values can be used to make sure that those files have not been altered in any way since your last authorized change or your last authorized configuration. So these are the key features of making sure that configuration management is done properly. And then the tools for this would be Ansible, Cisco DNA Center, SolarWinds Network Configuration Manager, right? See, this name is going to come up a lot. And Cisco is actually another one of those names that also comes up a lot. The packet tracer tool for Cisco can be used to create network diagrams and do a variety of designs and testing and looking. And I think it actually even can help with the IP address management. I don't know if it can help us with assigning new IP addresses. I think it's more for design and kind of learning how to create segments and use various tools and devices to create network diagrams and things like that. I do know that they have paid software, or maybe a paid version of the packet tracer that will allow us that would allow you to actually do the IP address management and assign IP addresses to the various Cisco devices or anything that's connected to the various Cisco devices inside of your network. So Cisco is another really, really big name in networking, And SolarWinds obviously is a big name. It's shown up in pretty much every example that we've talked about here. So the use case would be restoring a misconfigured router using the last known good configuration. So restoring a misconfigured router using the last known good configuration would be what? You have the centralized repository of your configuration files. The last configuration file that you had that worked perfectly, you would use that one to restore the new router because it's not working. And then of course you would document all of those changes, the reasons why it's not working, the problems that it's having, and look at the configuration file to see what changes were made that were not working well. But before you can do all of that, you need to first restore it so that the network is still working and it's doing what it's supposed to do. So you just use the last known good configuration file to make that change, and then from there you go and you troubleshoot why that misconfiguration happened in the first place. So we have a few benefits here for change and configuration management. I would say these are key benefits, but there are very many benefits as we've kind of gone through it, and organization and all of that stuff. But so reducing the downtime that's caused by poorly planned changes would be a big piece. Improving accountability by documenting all of the actions of the employees and every of the departments in the company. Enhancing security by ensuring configurations comply with policies, and then using things like the hash values and the checksums to make sure that those files have not been altered or changed, and the integrity of those files has not been affected, and it still falls under security and making sure that everything is being done with proper authorization. So these are just the key elements of changing configuration management. But really, when you look at the various descriptions of these things, you can probably come up with your own list of the configuration benefits or the configuration management benefits or the change management benefits. And I mean, as extra credit, as like homework, just to kind of get you the wheels in your brain turning, try to come up with a couple of extra benefits that you can think of, and then just drop them in the comment section and let me know what you come up with. But these are just our core benefits that we have in our current training. Okay, time for some scenarios, and this is for the organizational processes. So, organizational processes in operations. I think I referred to it as operations multiple times, but the technical term is organizational processes. So scenario one is the network diagram for troubleshooting, and the problem is that a device loses connectivity to the network. So we would refer to the physical and logical diagrams to identify the root cause. Find the device, find what it's connected to, and what potentially may be the cause of that connectivity issue. Situation two would be the IP conflict prevention using IPAM, the IP address manager. And the problem is that devices frequently experience IP conflicts. So we need to implement an IPAM system to track and allocate IP addresses efficiently so that there is no clashing of IP addresses and the same IP address is not being issued to multiple devices inside of the network. The SLA compliance is another one. So the problem is the internet service provider fails to meet the agreed uptime in its service level agreement. So then we use the service level agreement to hold the provider accountable and request compensation, right? At least pay us our money back. If you don't want us to change our service provider, you need to give me a prorated refund because you told me that you were going to be up for X amount of time and we have had too many interruptions. The scenario 4 would be the controlled firmware upgrade, and the problem is that there is an unplanned firmware update that's caused by the network downtime. So we need to update the firmware, right? So we would use the change management processes to schedule and test updates before implementing because there was the unplanned update that caused network downtime. So you need to use that to test the update, right? Like do it in a controlled environment before implementing it to the rest of your network so that you don't have the network downtime as a whole, right? And then finally, we have the configuration rollback. So the problem is that a recent router configuration change disrupted traffic flow, and now we need to use configuration management tools to roll back to the previous stable version. For example, go to the log files that you have stored, your repository of configuration files, and use your most recent configuration files that was successful and it was useful and worked properly, and then revert back to that last configuration, and then try to figure out exactly what happened with the recent configuration change that disrupted your traffic flow. Which brings us to our practice questions for section 3.1, organizational processes. So, what is the primary purpose of a network diagram? To track IP address allocations? No, that would be IPAM. To visualize the physical or logical structure of the network? That would be my answer. Enforce service level agreements? That's not it. Monitor device performance in real time? That would also not be it. So visualize the physical or logical structure? Excellent. Which tool is commonly used for managing IP address allocation and preventing IP conflict? So we're talking about IPAM, right? So IP address management software, I mean, it's literally right here. Cisco DNA Center is not for IP address management or the allocation. It was under, I think it was under like change management or one of the things that we were doing. SolarWinds Network Performance Monitor, also not the thing. Ansible, also not the thing. So IP address management software would be the answer. What does an SLA, service level agreement, typically define? The exact hardware configuration? No. The frequency of firmware updates? Potentially. The level of service a provider will deliver to a client, including uptime and response times? Definitely. That would be the answer. What is the first step in the change management process? So you need to submit a request for the change to your hierarchy of people, to whoever your upper management, your C-suite executives, whoever those people are that would actually approve that change request. So that's the first step that we would do. Which tool would best help to restore a misconfigured router to a previous stable state? IPAM software is for IP address management, network configuration manager, network performance monitor, and the SLA documentation. SLA documentation has nothing to do with this. IPAM software has nothing to do with this. Now, a performance monitor is for monitoring the performance of a network device or a network segment. So it's not for restoring misconfigurations. So it's literally in the name. The network configuration manager would be the tool that we would use to achieve this. Excellent. What is the primary benefit of using configuration management? So tracking changes and ensuring network configurations are consistent and compliant. It's pretty solid. Monitoring real-time device performance, visualizing the logical topology, allocating IP addresses. This is IPAM. This is network diagram. Monitoring. This is network monitoring. So what do we have? Tracking changes and ensuring network. What is a key component of a service level agreement that is related to performance? So uptime, right? So network topology diagrams, no response and resolution times for incidents. Okay. Configuration and change documentation, not really. Firmware update schedules, not really. So it would be the response and resolution time for incidents. It's related to the performance of the vendor. Very good. Which tool is most appropriate for creating network diagrams? Microsoft Visio was the first one, so that stands out. Ansible, Infoblox, and DNA Center. These are definitely not for network diagrams. I think it's Visio. Yeah, it is. So, I mean, this is the second question that we have that is asking us about the details of these tools. So it is a really good idea to look at the list of the tools that I gave you. And then, of course, in the practice examinations at the end of this document, the training document that we're using, there was the whole list of practice exams, all those links to those practice exams. And those are also going to be, sorry about that, I just had a cough attack. I think I've been talking for too much. When you use those practice examinations, you're probably going to see a lot of questions that are specific to these various tools and for the purposes that they serve. So getting familiar with these tools is very, very important. I'm going to show you certain lab exercises, and we're going to use a number of these tools, but we're not going to use all of the tools. So This is something that I think it's a part of that self-study element of this, especially if you're trying to become really functional as a network admin or a network engineer. So doing that self-study and actually doing your independent research and finding out what the different tools are for creating network diagrams, for example, or doing configuration management or IP address management or all of these things, looking at all of the tools, the top tools that are available for it. And you don't need to memorize them and you don't need to learn how to use every single one, but you should know which categories they fall under. And if you look at the top tools for Network Plus, for example, for each individual segment. And that, again, there's just a lot of those practice examinations that are going to help with this so that you can see the types of questions that are being asked so that you can prepare for what is specifically going to be covered in the Network Plus examination. So just kind of work your way backwards with those practice exams. If you have access to, Hackaholics Anonymous agents, guardians, or the master levels, if you have any of those memberships, then you will get access to those practice exams as a part of the downloads, as well as these practice questions, this slideshow that we're using right now. So I would just highly recommend going through those and making sure that you are solid with your knowledge awareness of these tools. So next question, what is a post-implementation review in the change management process? So after you've applied the changes, after you've implemented your changes, post-implementation review is to test configuration. No, this is before deployment, so this has nothing to do with this. Documenting the network's physical topology. No. Evaluating the success of a change and addressing issues. That's probably good. Approving a request for change is at the very top of this process. So this has definitely nothing to do with it. This has nothing to do with the implementation of the change management process at all, I don't think. So evaluating the success of the change, and which process ensures that firmware updates are tested and scheduled to minimize disruption. Is it configuration management, SLA compliance, change management, or IP address allocation? So the change management and configuration management are the only ones that stand out. Now, when we're talking about updating firmware, I think that actually falls under configuration. Change management is when you're trying to change a service provider, for example, or when you're trying to change a specific process that's being done in the company. So configuration management would fall under the firmware update of a software, right? But it says change management. No freaking way. I need to verify this answer. How can it be change management? Oh my god, I'm so pissed. Let me see. Yeah, that was the last question anyway. So I need to verify that question because I'm so pissed. If I did get it wrong, then fine, I'll admit it, but I need to verify that was the right answer. I mean, I guess so. Change management, I guess, is the thing. So ensuring that firmware updates are tested and scheduled. Okay, so now let's look at the notes to verify this. Okay, all right, fine. So the use case is upgrading network firmware while ensuring minimal disruption. That's actually one of the examples of change management. So fine. And verifying the changes in a staging environment. Fine. I think I was thinking about something completely different when I looked at the internet service provider example. And yeah, that's my bad. Yeah, that's the service level agreement use case that I think I was thinking about. So, all right, fine. I got it wrong. Whatever. I'm allowed to get wrong answers every once in a while, right? I think. Hopefully. Anyways, all right, moving on to monitoring and optimization. To get access to the Network Plus notes as well as the mock exams and the practice question slides, join the Hackaholics Anonymous community. If you join as a cyber agent, cyber guardian, or cyber master, you'll get access to all of the notes, the mock exams, and practice question slides, as well as many other perks that are available to Hackaholics Anonymous members like Python automations and exclusive content, as well as monthly live streams with me. And to join, you can click the link in the description below, or you can go to our homepage and click the join button there, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now let's get back to the Network Plus training. once everything has been set up inside of your network physically, so we're talking about the physical infrastructure, you have your racks and of course the devices themselves and the various machines and the wires and the cooling and the heating, all of that stuff. So once everything has been set up, now it's time to monitor everything and monitor the actual network itself. And so far, you've gotten pretty much a strong foundational and education on what all of the building blocks of a network are, including the things that you see and the things that you don't see. So we have the physical as well as the logical and technical. And now it's time to monitor all of that stuff. So this is where monitoring and optimization actually comes in. So we monitoring and optimization, by doing so, we actually ensure the network's performance, the availability of the network, the security of the network, and then we can use tools like the SNMP protocol, SIM software, packet analyzers. By using those tools, admins, which would ideally be you can detect issues, you can analyze trends, and you can maintain optimal network health. And establishing performance baselines and monitoring key metrics allows for proactive management and timely troubleshooting. And the baseline is essentially what the network is supposed to be like. And you'll hear that word a lot. So you're going to compare everything to the baseline, to the norm of the network. And once you have your baseline, and most likely the baselines will be established before you even get into the company, unless it's like a brand new company and they're starting a network, or you're completely revamping the physical infrastructure of their network. Unless those types of setups are being taken place and you're involved with them, most likely you're going to be hired onto a company that already has all these things set up and they know what the baseline is. And then they give you that data, and then you monitor the network and the performance of everything according to a comparison to that baseline. And if anything varies from the baseline, then you will go ahead and troubleshoot or manage or optimize, whatever it may be. So let us get into the details now. The most basic tool, our most foundational tool for monitoring and optimization is the SNMP protocol. So the Simple Network Management Protocol. And we touched on this as we were going through the ports and protocols section. But SNMP is the protocol that's used to monitor and manage network devices such as routers, switches, and servers. And this comes pretty much pre-embedded with every single machine that at the very least has these 65,000 plus ports. One of those ports is going to be the Simple Network Management Protocol. Obviously you have to set it up and you have to configure it so that it actually can detect and monitor the routers and switches and all of the various network devices. But once it's set up, it's something that comes kind of like out of the box with every type of computer and operating system. So the key features would be that it collects data about device performance, the uptime of the devices, and any errors. It uses agents on devices to communicate with a central SNMP manager. So each device serves as an agent, or each device would have an agent. And then there is the manager. So the SNMP manager will end up being the central server or the central computer that collects all of the data from these various agents, and it helps to monitor all of these agents on all of these devices that you have. We have the SNMP V1, V2C, and V3. And V3 provides enhanced security with encryption, which is ideal. And that would be the one that obviously you would choose if you had the choice. And use cases, we have the monitoring device health, which is the CPU usage, so the central processing units usage, the memory, which is also known as the RAM, the bandwidth, etc., etc. There's other data and analytics as well, other metrics. And we have generating alerts for hardware failures or performance issues that will also happen. Most likely, unless you actually integrate this with some kind of a GUI, graphical user interface, most likely you will be dealing with this on the command line. So you do need to obviously know the command line. But there are possible ways that you can also integrate this with GUI solutions, with graphical user interface solutions. So it's more point and click and kind of like looking at graphs and charts and things like that. So It's a little bit easier and more user-friendly if you actually get the GUI. But if you know how to use it on the command line, then you'll be able to check on your devices from any machine on any server as long as you have the correct credentials and the login mechanisms. Then you'll be able to check in on all of your devices as long as you have access to a command line. So that is it for the Simple Network Management Protocol. Now, the SIM is actually one of these software solutions that really takes care of a lot of things. So usually the context that we talk about SIMs is under security, so security information and event management. And it's basically a tool that collects and ingests log sources or logs from various sources. And maybe it's not even logs that are being fed into it. Maybe it's actually monitoring traffic in real time because it's connected to various ports on the network. But for the most part, it takes data from a variety of different sources, sometimes dozens of different sources, if not hundreds. And it'll ingest all of this data in one central location. And then it'll analyze all of that data and see how it correlates to each other. So how the network logs correlate with the authentication logs and how those correlate with syslog and all of these various log sources. And it'll start looking at IP addresses and certain activities, and it'll start generating potential alerts to see where if there are any security threats that are happening against your infrastructure, against your network. And these are very powerful tools. SIMs are, I would say, like the first type of AI, in my opinion, because they can sift and sort through so many different log sources and then analyze them and correlate how all of those data points connect to each other, all those events connect to each other. And then it'll start giving you alerts and things that you should pay attention to. And the dashboard is very user friendly, and you can obviously go further into the details of each event and look at the code that's associated with it and the IP addresses and the protocols, all of those things that are associated with them. But the dashboards make it super user friendly so that all in one central location on one screen, essentially, you can get to see what's going on with the entire network. And they're very, very, very powerful tools. They centralize log collection and analysis. They have real-time alerting and reporting for suspicious activities, and they support compliance with regulations. For example, the General Data Protection Regulation, or HIPAA, the Health Insurance Portability and Accountability Act. So there's a lot of different regulations. There's a lot of freaking compliance guidelines, and you want to adhere to all of them. So these tools help to make that happen. The most famous examples of these tools, I would say the most famous example is Splunk. Splunk is kind of like the industry standard. It requires a paid license, so you can run it on a free license or like just kind of like the free version, but it is the functionality is very limited compared to what you would get if you got the enterprise version of Splunk. And they give you like a free trial when you use the enterprise version, but after I think 2 weeks or something, it goes into the paid, and it's like I think like $300 a month or something like this. So it's like it's not for like a single user, you know what I mean? It's definitely designed for a company, and it is it's like very, very powerful. And then we have the IBM QRadar, as well as the ArcSight, and these are of course competitive tools to Splunk, and they're very, very powerful, and in their own right they're super functional. But when it comes down to SIM, everybody who is anybody knows the name of Splunk, and for the most part they use Splunk. There's also something called Elk Stack, Kibana and Elk Stack. Elk Stack is also known as Elastic Stack, and it's an open source platform that allows you to ingest logs, essentially do the same things that Splunk does. It's just a little bit, I would say, it's the setup is a little bit different. The functionality is fairly similar, and you can still use it as a SIM and be able to collect logs and ingest them and analyze them and correlate events, so on and so forth. So the open source version would be Elastic Stack's 3 different main softwares that go together. There's Elasticsearch, there's Kibana, I forget the third one. but Logstash. There you go. Elasticsearch, Logstash, and Kibana, and they make up for the Elastic Stack, and it's open source. So use cases for SIMs would be to identify unauthorized access attempts. It would be to correlate events to detect and mitigate advanced persistent threats, which is a really big deal. And as the name implies, it's advanced, meaning that they really know what they're doing. It's persistent, meaning it's not just one day or one event. They're constantly trying to hack you. They're constantly trying to break into your network. And this goes across days and weeks and months, sometimes years, until they actually achieve their objective. So APTs are a really, really big deal. A website that I recommend you check out is MITRE, and there's something called the MITRE Attack Framework, which I'll just real quick show you, because I think it's very, very important. It's like one of those tools that if you get to see, it ends up being extremely useful. So on the MITRE Attack website, and this is how you spell attack, ATT_CK. This is the attack matrix for enterprise, and for all these are the various techniques and tactics that are used to attack somebody or to attack a company. And obviously you can see the list is very long. But then one of the other things that you can actually do with MITRE is that you can go ahead and check out the various organizations or the various groups that have attacked companies. And so when we go under CTI for cyber threat intelligence, it's at the top right here, and we click on groups, it brings us this list, this massive list of these various groups that have attacked organizations or countries or whatever. And so you'll see this a lot. You'll see APT3, APT30, 32, it just keeps going. And these APTs stand for Advanced Persistent Threat. And these are APT groups that have not fully been identified, but their tactics have been identified. And so APT-1 is a Chinese threat group that has been attributed to the 2nd Bureau of the People's Liberation Army, the General Staff Department's 3rd Department, commonly known as its military unit cover designator as Unit 61398, right? So you have these types of groups, and then we actually have Aquatic Panda, for example, is a suspected China-based threat group with a dual mission of intelligence collection and industrial espionage, so on and so forth. So certain groups actually will have names. So for example, Chimera, and of course Dark Hotel, and There's so many of them. But then there's also the ones that have not been identified, so they will have these APT, and then there's some kind of a number that follows it, that is the identifier that is being used to identify them. But if you're interested in security, this is a invaluable website. The MITRE Attack Framework and the Matrix is absolutely necessary for everyone and anyone who wants to go into security, because it provides so much intel on the tactics, the techniques, the groups, and all of the procedures that they've used to achieve what they've achieved. And it's just, again, it's invaluable. This is like a really, really powerful source, a very, very useful source. So this is what the APT kind of connects us to. So whereas we looked at advanced persistent threats, this is what we are narrowing this whole thing down to. So SIMs will actually help you be able to, at the very least, hopefully correlate with something like the MITRE Attack Matrix, and from there to be able to identify, detect, and mitigate advanced persistent threats and things that are happening against your network. Now, the packet analyzer is probably the tool that you will end up working most with as a network administrator. And packet analyzers are specific to capturing and inspecting network traffic to diagnose issues and monitor activity. If you have a security background, this is going to be also super useful when you're analyzing packets, because within the contents of the packets, you can potentially notice suspicious activity. But at the very least, it'll help with troubleshooting, because you get to analyze the packets that go in and out of a network, and you get to see kind of reverse engineer where issues may arise. So key features of a packet analyzer would be that it provides granular visibility to packet level data. That means you get to see all of the details. The granular stuff is the nitty gritty, the details, the hexadecimal code and the ASCII code and all of that stuff. You get to see that the very, very fine details of the packet level data. You get to analyze protocols, source destination addresses, and payloads that may be attached to certain transactions. And the industry standard, the biggest names in this packet analyzer world is Wireshark, and then TCP dump is the command line tool, the command line version of it. And I mean, Wireshark, again, is an open source tool, very, very powerful. You can do a lot with it just from installing it. There's also a command line version of it called T-Shark. It's not as fully functional as Wireshark, but it offers a lot of the same features that Wireshark does. So if you know what you are looking for, and if you're comfortable with the command line, then T-Shark would be the go-to, but Wireshark by itself is just absolutely amazing. It can capture traffic from various interfaces on the network, or various, you can upload packet capture files to it, also known as PCAP files. And from there, you'll be able to analyze traffic and so on and so forth. So we'll also end up using Wireshark to go ahead and look at some sample PCAP files, and to be able to identify certain pieces from it. So very, very, very useful tool, very powerful tool. Highly, highly recommended. Use cases for packet analyzers would be to troubleshoot connectivity problems, to detect abnormal traffic patterns, for example, a DDoS attack. And the thing with this, with Wireshark and TCP dump, is that it doesn't operate like a SIM would. It doesn't operate like Splunk would, where it analyzes the traffic and it gives you an alert of a potential attack. You need to be able to detect it. You need to, as the investigator, as the analyst that's looking at the traffic, you have to be able to notice that, hey, this kind of seems fishy. We're getting a lot of pings from this IP address in a really, really short period of time. I think they're trying to do a DOS attack against us, a denial of service attack. Or we're getting this one particular port on our network is getting bombarded with traffic from a variety of different IP addresses, and it's happening in a really short period of time. I think it's a distributed denial of service attack. So a distributed denial of service attack is basically the same as a DOS attack, except it's coming from a dozen different IP addresses, or 100 different IP addresses, 1,000 different IP addresses, but it's going against a specific location, trying to bring a service down, or trying to bring a segment of your network down. So it's a big deal, because if it actually succeeds, then the service that you're running, that your legitimate users or customers are using, it's going to crash, and the service is going to be denied to those legitimate users. So you have to still be able to detect it, though. So Wireshark is not going to say, hey, you're under a DOS attack. It's not going to do that. It's going to just give you the excuse me, it's going to give you the data, and then from there you have to analyze to see if you're under attack. Which brings us to the concept of the baseline. So the baseline, or baselines, represent the normal network performance under standard operating conditions. So this is the norm, right? This is what the network should look like. This is what activity on your network should look like. If you're setting up a brand new network, or if you're setting up brand new software or infrastructure, physical devices on the network, you have to establish a baseline. But again, for the most part, if you're going into a company that's already established, they're going to show you the baselines. They're going to give you the data of the baselines, and most likely it will already be fed into whatever software you're going to be managing and monitoring. And all you have to worry about is any alerts that come in and responding to those incidents, right? So for the most part, I think for most people who are watching this, I think you're going to end up going into a company that already has their baselines established. Now, if they don't, then you need to establish them. And the way that you do that is by monitoring the network traffic and looking at what's going on. And then most likely what's going to happen is you're going to get a lot of false positives, because a user that was trying to log in ended up entering their password incorrectly multiple times, and they got locked out. And then you have to go ahead and look at that and be like, oh, no, this is actually one of our users. You try to contact the user. Hey, were you trying to log in? And they're like, yeah, sorry, I just came back from vacation. I forgot my password, whatever. Like, there's false positive alerts that come up that you start flagging them as false positives, and little by little you start tweaking the alerts that come in to say, okay, these were false positives, so this is a part of our normal baseline. And then you have to also pay attention for false negatives. And this is where your skills as an investigator comes in, where you look at the traffic and you're like, oh, you know what? This actually kind of seems fishy, and it bypassed whatever our detection mechanism was. And we need to flag this as a fishy event because this IP address is on the virus total database as a malicious IP address, something like that. And I'm kind of oversimplifying it, but you tweak all of the traffic until it establishes the baseline, if you are helping to establish the baseline. But again, I really think for the grand majority of people that are watching this are going to go into an environment where the baseline is already established, and now you're just monitoring to see if there are any variations or deviations against those baselines. The key features of the baseline are that they're established by collecting data over time and making optimizations and tweaks. They include metrics like latency, throughput, and error rates, and it provides a reference for identifying anomalies. So, use cases are comparing the current performance against the baseline to detect issues, and then evaluating the impact of network changes. So these are just some of the use cases where a baseline becomes very handy. And I mean, again, as you're monitoring traffic on a network, you knowingly or unknowingly are using the baseline. Everything is being compared against the baseline. And if the SIM tool, if Splunk gives you some kind of an alert, it's comparing it against the baseline. And it's saying, hey, listen, this is like an anomaly. This is something that does not happen regularly. And I've never even seen this happen in this network traffic. And you need to pay attention to this. And that's how you will step in and be like, okay, let me go investigate this further and see what it is. And Splunk will not take action for you. So if something needs to be blocked off from the network, that would be done manually by you, unless you have something called a SOAR, which is kind of like the next level of a SIM. And the SOAR is the security orchestration and automation response that automates the response. So it'll actually block something, right? It'll block the malicious IP address, and it'll stop it from doing any more scans or any more attempts at logging in, so on and so forth. So SIM and SOAR go hand in hand. These are some of the key metrics for monitoring and optimization. So these are important. You'll hear these words a lot. We've already actually mentioned them several times in this training series. So we have latency, which is the time that's taken for a data packet to travel from the source to the destination. So speed, essentially, measured in milliseconds. And the lower latency is critical for applications like voice over IP and online gaming. So you want high latency, right? So, lower latency. So a lower millisecond, a lower time that's taken for data packets to travel. That's critical, meaning that it's actually essential. It's necessary for applications like VoIP or online gaming, because its speed is very, very important, right? And so as one of the examples that I mentioned earlier, it's like when you're doing online gaming, if you're connected to Wi-Fi versus connecting to an actual Ethernet cable, most likely the Ethernet cable will have a lower latency. It'll be faster because there is no obstructions, right? There's no walls that are blocking the Wi-Fi signal, for example, and there's no jitter, which is the variations in the packet delay. There's no anything like that. There's no packets that are lost, or there's no traffic that's lost, because it's literally hardwired to your computer. So you have the strongest potential connection possible. Wi-Fi compared to Ethernet cables is kind of like night and day, really. The speed can also be drastically higher as well when you have an Ethernet cable. So the latency will be much lower when you have an Ethernet cable versus using Wi-Fi. So latency is the time that's taken for a packet to travel from source to destination, and you want low latency, meaning you want the lowest milliseconds so that it achieves it gets to its destination faster. Throughput, on the other hand, is the amount of data that's actually successfully transmitted over a network in any given time. And this is measured in bits per second, so BPS. So the amount of data in bits per second is how we measure throughput. And this is the data that successfully transmits over the network in any given time. The base measurement is second as the time. Jitter is variation in packet delay, so affects real-time applications like video conferencing and video gaming, for example. Jitter is the variation in the delay, so it's the variation in the latency, right? So how long does it take for the data to actually be delivered from the source to destination? That would be jitter, or that would be latency, but then jitter is the variation in that speed, in the amount of time that's being taken for things to be delivered. So this affects real-time applications like video conferencing or anything similar to that. Packet loss is the percentage of packets that fail to reach their destination. This one's kind of a gimme. The name kind of just says it all. High packet loss indicates congestion or hardware issues, or somebody has hacked into your network and they're sitting in the middle. So a man-in-the-middle attack where you have your source IP and then you have your destination IP, and there's somebody sitting in the middle and capturing the traffic that's going back and forth between these two IP addresses, and they may be stealing the data. So that packet could be lost in transit and you're wondering what's happening and your data is being stolen. So that could be an issue as well. So the percentage of packets that fail to reach their destination is packet loss. And then we have availability metrics. So we had performance metrics, and then now we have availability metrics. So uptime and downtime are really key metrics when it comes down to network performance. So uptime is the percentage of time that a network or device is up. It's operational, it's running. Downtime is the amount of time when services are unavailable, right? So you want to have the highest amount of uptime and you want to have the lowest amount of downtime. So as an example, the service level agreement that we talked about earlier, guaranteeing that you're going to have 99.9% of uptime, allows for 43.8 minutes of downtime per month, right? So if you say, okay, how many minutes are in a month? We can say, okay, out of all of those minutes in 1 month, 99.9% means that these many minutes we have to have service, which leaves us with 43.8 minutes of downtime per month. Now, I don't know if they're calculating a 30-day month or 31-day month. I'm not that great with calculating numbers like that. But if I had my calculator handy, I'd be able to tell you. So you can just run the exercise. You could literally say, 60 minutes times 24. So that would be the number of minutes per day. And then you would multiply that by 30, let's say if you want to calculate a 30-day month. And then from there you say, okay, so what is 99.9% of that result, that value? And then you say, okay, so we need to have this many minutes that are up, which means that out of the total amount of time per month, it leaves us with, let's say, 43.8 minutes per month that you can be down, which is for a company that's like doing millions of dollars per minute or something, or like millions of dollars per day or something like that. 43.8 minutes of downtime is really, really bad. Like, it's crucial, right? So even with 99.9% of uptime, the 43.8 minutes can actually cost a lot of money to a company. So if they don't meet this, right? So if there's an hour and a half of downtime, you need to call them and you need to be like, listen, you just lost us this many dollars, and you need to refund me my money that I'm paying you, because in your agreement you said that I would not have any less than, or any more than 43 minutes of downtime. That's essentially what you said in our service level agreement, and you just cost me a lot of money. So mean time to repair. So mean stands for the average, and so this is the average time to resolve an issue. The mean time to repair, MTTR. The average time to resolve an issue. The mean time between failures, the average time between equipment failures. So did it take us, on average, does it take 3 months until we see another equipment failure? That could be the average time. Does it take us 6 months to see another failure? That could be an average time. So the mean time between failures should be high. You would want the highest mean time possible, MTBF. You would want the highest mean time possible, because it means that your system is running smoothly and your network is running smoothly and you don't have failures. The mean time to repair, which is the average time to resolve an issue, this should be the lowest number possible, because you don't want it to take forever to fix something. And then you have the error rate, which also should be the lowest, right? So the number of errors that are encountered per unit of data that's transmitted, you also want this to be a low value. So uptime, we want to be really high. Downtime, we want to be as low as possible. Mean time to repair should be as low as possible. Mean time between failures should be as high as possible. And error rates should be as low as possible. All right, scenario time. So scenario 1, we have identifying a bandwidth bottleneck with the SNMP protocol. So the problem is that the users report slow internet speeds. So we use SNMP to monitor the interface bandwidth usage and identify overloaded links. That's something that can be used, or that's something that can be done using SNMP. So you're looking for bottlenecks, right? So bottlenecks meaning that there is a bunch of traffic coming in this one particular location, and it's now overloaded. And it's, if you can just imagine what a bottleneck looks like, it's like the bottle itself is very thick, and then when you get to the neck of it, it gets really thin. So that's what that looks like. Is, or you can kind of look at, you can think of a funnel as well. The top of the funnel is going to be very wide, and the bottom of the funnel is super small. That can also be another way that we can look at this. So when there's a lot of traffic coming in one specific location, and now there's congestion, that can be considered a bottleneck. And so we're looking at a lot of traffic, it's overloading that link, right? Scenario 2 would be correlating the security events with the SIM, Security Information Event Manager. The problem is that there are a series of failed login attempts across multiple systems, and the SIM will correlate the logs to identify a coordinated brute force attack. These things are amazing. They're such powerful tools. Scenario 3 would be diagnosing packet loss with a packet analyzer. So the problem is that the VoIP, the voice over IP calls, experience choppy audio. It just gets cut off a lot. So we use Wireshark to analyze the packets and identify excessive retransmissions or congestions against the IP addresses that are assigned to our phone systems, right? Then we have the scenario for comparing performance to baselines. And the problem is that the application performance degrades after a network update. So we compare the latency, the amount of time that something takes to get from source to destination, and throughput, the amount of data that gets there in milliseconds, bits per seconds, excuse me. We look at the latency, which is the speed, and the throughput, which is the data that actually gets there, to establish baselines to identify anomalies. So these are our 4 little scenarios. Now, time for practice questions. Alrighty, so here we go. Which protocol is commonly used to monitor network device performance, such as the CPU usage with bandwidth? So protocol, okay, we're thinking about a protocol. A SIM is a tool, TCP/IP. I mean, technically it is protocols, but it has nothing to do with looking at network device performance. And then the OSPF, open source performance monitor or something like that, or no, open shortest path first. That's what it is. So open shortest path first also has nothing to do with monitoring network device performance. So it's the simple network manager protocol, and that would be our answer. What is the primary purpose of a SIM tool? To monitor device health and generate performance alerts, to capture, analyze packet level traffic, collect, analyze, correlate logs to detect security threats. That would be my answer. Manage IP address allocation and subnet usage. Collect, analyze, correlate logs. Yeah. Which tool is best suited for diagnosing packet loss and abnormal traffic patterns? So a SIM, packet analyzer, SNMP manager, network configuration manager. Configuration manager is looking at the actual configuration of the network, and it could be something that we would use after identifying why we have packet loss and abnormal traffic. SNMP manager would be pretty solid response. Packet analyzer would also be a solid response. SIM is more for security and ingesting logs from various sources, and so I would say packet analyzer. Very good, cool. What does a network baseline represent? So the highest level of performance a network can achieve, the standard operating conditions of a network performance, total bandwidth capacity of a network, the configuration settings. So it's the standard operating conditions of a network performance, the standard, the norm, things that should be going as business as usual. That's what a baseline represents. Which metric measures the variation in packet delay affecting real-time applications like VoIP? So variation in packet delay or variation in speed, we can think about it, right? So latency is the actual speed measured in milliseconds. Throughput is bits per second, the data that's actually being transferred and getting there. Jitter is the variation in that speed, the variation in that delay, and then packet loss is the amount of packets that are lost. So jitter would be our answer. What is a typical feature of SNMP v3 that is not available in earlier versions? So monitoring is available in all of them. Enhanced security with encryption and authentication, that was the one. Support for multiple network devices, automatic network diagram generation. It would be B, the enhanced security with encryption and authentication. Which metric indicates the average time that it takes to resolve a network issue? So average means what? Mean. And then time to resolve a network issue. Mean time to resolve repair. That would be our answer. What tool would you use to detect and correlate unusual login attempts across multiple systems? That would be our beautiful friend, the SIM. The IP address manager helps to manage IP addresses and assign IP addresses. Packet analyzer captures traffic and helps you analyze those packets at a granular level, but you have to be the one to detect and correlate the login attempts. It's not going to do it for you. And the network manager protocol is just a protocol that we can use to manage the network devices, but it's not going to detect and correlate login attempts. So that would be the security information event manager, the greatest tool ever. If a network has 99.9% uptime, how much downtime is allowed per month? This is kind of tricky because we don't know the number of days per month. But if we look at the example that we got earlier, it was 43.8 minutes. So here's what I'm going to do right now. I'm going to pull out my calculator and I'm going to analyze the numbers that we get. So we are going to go ahead and we're going to say a 30-day month, okay? So actually, no, let's do it like this. So we'll do 24 hours times 60 minutes will give us 1,440 minutes per day. So if we multiply that by 30 days, that's 43,200 minutes per 30-day month. And then so we now take 99.9% of that. And oops, I did that incorrectly. Hold on one second. So dang it. So 1440 times 30 one more time. So 4320, and we multiply that by 99.9. I multiply it by 0.999, which is 99.9%. So that will give me 43,156.8. So if I subtract that from 43,200, which is our total, that ends up being 43.2 minutes, I guess. So maybe my calculation was a little bit off, but essentially it's this number right here. So 43.8 minutes. This is being calculated based on a 30-day month. I just got 43.2. So somewhere in my calculation I was wrong, or maybe somewhere in their calculation they were wrong. But basically, this is the closest number. So 43.8 minutes would be the amount of time in a 30-day month that you can have as downtime. So what does throughput measure in a network? So throughput is the data in bits that's actually being delivered to its destination, and it's being measured based on a given amount of time. So the example that we had was bits per second. So the percentage of packets lost during transmission, that's packet loss. The time a data packet takes to reach its destination, that would be our latency. The amount of data successfully transmitted in a given time is throughput. Variation in packet delay would be jitter. So amount of data is the one. And that's it. We got it. So disaster recovery and continuity is next. To get access to the Network Plus notes, as well as the mock exams and the practice questions slides, join the Hackaholics Anonymous community. If you join as a cyber agent, cyber guardian, or cyber master, you'll get access to all of the notes, the mock exams, and practice question slides, as well as many other perks that are available to Hackaholics Anonymous members, like Python automations and exclusive content, as well as monthly live streams with me. And to join, you can click the link in the description below, or you can go to our homepage and click the join button there, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now let's get back to the Network Plus training. All right, continuing with our network operations journey here, we have disaster recovery and continuity. And this is really, they go hand in hand, obviously. And this has a lot to do with just your backup plan, your contingency plan, and how to prepare just in case stuff hits the fan. If you know what I mean. So usually disaster recovery has to do with actual natural disasters and not so much if you get hacked, but that is a part of the disaster concept as well. So if actually somebody hacks the network and holds you at ransom, that technically can be considered a disaster. And then you have to try to plan for that and how will you recover from that. And continuity really refers to how can we make sure that the business continues and operates, and there's something called business as usual. How can we get back to running our business as usual as soon as possible, right? So this is the concept behind disaster recovery and continuity. And so DR, disaster recovery and business continuity planning, ensure organizations can quickly recover from unexpected events like the hardware failure, cyber attacks, natural disasters, and understanding disaster recovery metrics and site types is critical to minimizing downtime and data loss while maintaining essential business operations. And site types has a lot to do with if you have partially it's like, okay, do we have a hot site? Do we have a warm site or a cold site? And that has everything to do with how live that environment is. So if it's a hot site, that means you are running operations at that location. If it's a cold site, that means this is like a backup location where we just store our devices and storage drives and data drives, so on and so forth. And then there is the location actually being next to a disaster zone. That could be a part of it, where it's like, are you residing on a fault line, an actual earthquake fault line, or how close are you to the earthquake fault lines? How close are you to an environment that can potentially be hit by a hurricane or some kind of a tornado or something, like some really crazy natural disaster? How physically secure is the environment? How physically secure is the infrastructure of the network and the logical infrastructure of the network? Are we prone to cyber attacks? Are we prone to people trying to break into our building and attach something to our servers where they will steal data or where they start spying on us? How well do we actually maintain our hardware? As we looked at some of the different setups that we had for these server rooms, and we saw some of those crazy wires, and we talked about heating and the cold aisles and the hot aisles and all of that stuff that actually feeds into hardware failures. And then there's also the conversation of, how old is the hardware? When was the last time that we updated our hardware? Are we using our own on-site devices and on-site servers, or are we renting something from a cloud service provider? Because if you're renting it from a CSP, then really you don't have to worry about it, because they're constantly focused on updating their hardware, and they're constantly focused on making sure that at the very least their services are up so that you can just continue your business as usual. They have multiple warehouses of servers and across dozens of locations all over the United States or all over the world, really. And you can choose various locations as your redundant locations, that if your primary location fails, you have the backups. And I'm kind of getting ahead of myself, obviously, but there's a lot of different ways that we can make sure that we are prepared for a disaster and we can continue, the business can continue as usual if a disaster actually does hit. So let's look at those things. The first thing that we need to understand is the metrics, the data that is associated with disaster recovery in general. There's something called the recovery point objective, and this is the maximum acceptable amount of data loss that's measured in time. So meaning, how frequently do we actually have backups? And if something happens where we need to revert to our most recent backup, how far or how long ago was that, right? So has it been 5 days since our last backup? And so if we booted from our last backup, or if we restored our systems to our last backup, how many days has passed? How many hours has passed? How much data have we lost over the last 5 days, right? So that is the recovery point that we are talking about. And now the goal for the recovery point objective, right? That objective for the recovery point is to be as short as humanly possible, right? Shorter RPOs minimize data loss, but may increase backup storage and processing costs, which is understandable because you're making more and more backups. There is something called the sync backup. So if we do a synchronize instead of just making a whole new backup, meaning like just copying the data all over again and copying the data all over again instead of syncing the data, right? So a sync would be, if only out of, let's say, 50 folders, let's just talk about folders. So if we have 50 folders, if out of those 50 folders, only 2 of those folders have changed with some edits or updates to it, then when you sync your backups, all you're doing is you're just modifying the backup for those 2 specific folders because the rest of the 48 folders weren't touched, right? That's one version of a backup or a sync. Another one is, okay, you have 50, you have a copy of these 50 folders. For your next backup, you're just going to make another copy of those 50 folders. And now technically you have 2 copies of the full 50 folders and it's taking up twice as much space in your storage. So there are multiple ways to actually create backups, and obviously the more efficient one is to just do synchronized backups where you only copy or you only modify the changes that have been made. So you literally the backup itself is syncing and it's only copying or adjusting the changes that were made in the system. So shorter RPOs would be ideal. These are that's the goal really, but just depending on how much data you actually have and what your process is for creating those backups, it can take up a lot of storage if you have a lot of data. And I mean, especially for really big companies, they have massive amounts of data across thousands of employees and hundreds of different locations, and all of that stuff can be very, very expensive to back up. So maybe they don't do it as frequently, or maybe they don't back up everything. They only back up like the really, really critical stuff. There's a lot of different ways to get around this or to achieve this recovery point objective. But obviously the most critical infrastructure should be backed up and the most critical data should be backed up, and then you should be backing it up as frequently as humanly possible. So an example is if the RPO is 4 hours, that means that backups occur at least every 4 hours to ensure that no more than 4 hours of data is lost in a failure. So this is the maximum acceptable amount of data that we can lose measured in time. When was your last backup, right? Was it 4 hours ago? Was it 4 days ago? Was it 4 weeks ago? Was it 4 months ago? That all of that makes a really, really big difference. And of course, it has a lot to do with how active your environment is as well. If you don't have that much activity, then maybe you don't need to do as many frequent backups. But if you're a super live business and you're running 24 hours a day, then you really want to make sure that you have as frequent of a backup as possible. So recovery point objective being 4 hours is pretty decent. Another key metric for recovery points or disaster recovery is the recovery time objective. So this is the maximum amount of time to restore services after a disruption. And obviously you also want this to be as short as possible. So this influences the selection of your disaster recovery strategies and sources, and shorter RTOs require faster recovery solutions like the hot DR site, right? So we talked about hot sites and warm sites and cold sites. And a hot site means that everything is accessible on site. It's in the building. You can get access to everything really quickly. Or the drives are literally in the room, or you're very close to where the backups are being stored. A cold site is you have to drive somewhere, right? And that's how you access the data recovery or the disaster recovery. So we're going to talk about these various sites types in a little bit as well, but the shorter RTO is the goal, right? So if the RTO is 2 hours, if your recovery time objective is 2 hours, then your organization has to restore operations within 2 hours of disruption, which means you need to have at least a hot site that is readily available, that you can immediately go ahead and access all of the critical data and then reboot or recover from that whatever your most recent backup was, and do it within 2 hours, right? If the RTO is longer, then you can technically afford to have a warm site or a cold site. And a hot site could also refer to the actual storage itself. So if you have all of your data, external drives are literally plugged in, right? That could technically be a hot site. Or the data backups are actually on the system, right? So that could be a kind of a hot site. But if it's on the system and the system crashes, it kind of doesn't make sense. So it's probably best for it to actually be on some kind of an external, and we're just talking about data recovery. So disaster recovery could refer to, a router going down and you need to replace your router. So it's like, okay, do we have backup routers in the building? Right, that could potentially be a recovery point that you need to get back to. But specifically right now, we're talking about data recovery and recovering data. And the recovery point objective is going back to the amount of data that was lost. But this could also refer to your actual physical devices crashing and a wire burning, and you need to replace the wiring, or so on and so forth. So there's a lot of different ways that a disaster can occur, and there's a lot of different backups that need to be accounted for, a lot of contingency plans that need to be created, and some of it has to do with the physical devices, some of it has to do with data that's being lost. In this particular conversation, we're talking about data that is being lost, and data needs to be recovered, and systems need to be booted. So for example, a key server crashes and you need to recover the actual operating system for that server. So do you have an ISO image for whatever that operating system was, and do you have that sitting on a drive that you can easily just boot and restart that server and then get back to the recovery point within 2 hours, right? So to make sure that your recovery time objective is actually 2 hours, everything needs to be readily accessible, and your employees, the people that are in charge of this, really need to know what the hell they're doing, because you need to make sure everything is done within 2 hours. So when it comes down to doing jobs in IT, a skill is, I would say, almost as important, if not more important, than making sure that you just have the backups readily available. And people actually knowing what they're doing has a lot to do with how quickly this 2 hours is done, whether or not we can actually make it within those 2 hours, or it's going to take 4 hours because the guy doesn't know what he's doing and he needs to Google everything, right? So that has a lot to do with this as well. So as our comparison is concerned, the RPO, the recovery point objective, is the maximum tolerable data loss, and this is focusing on the data backup frequency. So how frequently are you backing up all of your data? And then there's the recovery time objective, which is the maximum tolerable downtime. And what we're focusing on is how long does it take to restore our services back to business as usual, right? So how frequently are you doing backups, and how long does it take for you to actually restore either your data backups, or if a system crashes, how long does it take for you to restore that system? If something is burned, how long does it take for you to replace those wires? How long does it take to replace a switch or a router? All of these things have something to do with the recovery time objective. Recovery point objective also has a lot to do with that as well. So data loss could actually be because the switch is down and now you can't get the data from your users. If your users are trying to access data on your servers, or if your employees are trying to access data to actually run the business. And the backup of that could also have to do with, do you have a backup data server, right? Do you have a backup server? Do you have a backup router to make sure that you are immediately getting back to business as usual? It's not just about, oh, do we have these files that are on this computer? Do we have a backup of these files? That's not necessarily the only version of this scenario. There are a lot of versions of these scenarios that actually have to do with, do we have a backup server? Like, do we, and again, this is why cloud service providers actually come in really, really handy, because you can just say, I want 3 backup servers, 3 redundant servers, just in case anything happens. I don't even want to experience any downtime, right? I just want these backup servers to kick in as soon as the first one goes down. I just want the secondary one to kick in, right? So, and we've talked about this already. So there's a lot of different ways to provide for redundancies. And a version of this is to just have data backups. Another version is to have backups of your systems, your actual physical devices, so on and so forth. Now we're going to talk about the disaster recovery site type. So site types provide alternate locations where business operations can actually resume during a major disruption. So a hot site would be a fully operational site with real-time data replication and pre-configured systems. So it's literally the backup site, the redundant site. It's a redundant site. It's fully operational, ready to kick in at a moment's notice, and we don't need to do any kind of setup because everything is being done in real time. The data is being replicated in real time. We have pre-configured systems running and ready to go. All we need to do is just press the on button and they will be fully functional, and we already have all the data that's replicated. So there's immediate availability with a hot site, right? The high cost of this it's understandable depending on who you are. Like if the business can actually afford it and if the business really needs there to be a hot site available, then they're willing to pay the high cost to this because its constant operation and maintenance it's literally as if you just have a second location that you're running all the time because it needs to be fully operational. This is the key element here, is that at a moment's notice, it needs to be like, oh, okay, we're just going to go back to the secondary site because site A, I don't know, went through a hurricane or somebody just broke in and decided to set fire to all of our servers, or I don't know what the situation may be, but there's a million different things that could occur, and you need to make sure that you actually have a secondary site that's available. And the most readily available version of it is the hot site that has real data replication. Everything's pre-configured, ready to go, right? So a mission critical operation during requiring minimal downtime, which would be, for example, a financial institution or a government entity or a hospital, right? So there are things that are really, really, really important, and they have to have these immediate backups that are available. And there's things like a hospital, people's lives are at stake, right? Financial institutions, people's money, which is their livelihood, that's at stake. So there are a lot of different examples of this, and something like the Microsoft website. So something happened early or like late, maybe mid to late 2024, where something happened. It was like some kind of a patch or something where any system that was using Microsoft was down for the day. And there was, some crazy amount of money that was lost by Microsoft because their systems across the globe were down and people weren't able to use anything that had Microsoft on it because there was some kind of issue that they needed to fix that they were working on fixing. And for that one day, it was like hundreds of millions of dollars that Microsoft lost. So a company like Microsoft, a company like Google has hot sites because for them to be down a day, it costs hundreds of millions of dollars. So it's obviously critical for them. Maybe it's not as, and I mean, a hospital uses Microsoft. So if Microsoft goes down, that means hospitals go down. A financial institution uses Microsoft. So if Microsoft goes down, that means banks can't operate. Does that make sense? So it's like there are so many different ways that we can think of a mission critical example, and that's why a hot site is necessary. A warm site is partially equipped and there's some infrastructure that's in place, but it requires additional setup. So the recovery is now going to be slower, obviously, compared to what a hot site would be. Anything other than a hot site is going to be slower. The cost will also be less than a hot site because you don't need to have exact systems readily configured, data being replicated in a live environment. So medium priority operations with acceptable return recovery time objectives that are in hours, right? So if you have a hot site, that means your recovery time objective is in minutes. If you have a warm site, that's like, okay, we can afford a couple of hours to get back to business as usual. And that means that it's partially equipped, it doesn't have everything that it absolutely needs, and some infrastructure is in place, but there's additional setup that needs to happen. So for example, we need to bring all of our backup drives and make sure that all of these backup drives are actually connected to these systems, so that these systems can now connect and access all of our data so that we can actually run the business. And that takes time, right? So your recovery time objective in this situation is hours. In a hot site, your recovery time objective is minutes, and you need to make sure that you are up and running as fast as humanly possible. Warm site has a little bit more leisure, and of course, as you can imagine, a cold site will have even more leisure, right? They have the luxury of taking more time to get back to business as usual. And this is the example of the cold site. This is basically a basic facility with no pre-installed equipment or data replication. Their RTO is in days, not hours or minutes. Obviously, it's going to be the lowest cost, the longest recovery time due to the need to set up the infrastructure from scratch. So maybe you don't even have your routers and modems. You have to go buy your routers and modems, and then you have to go connect your routers and modems, and then you have to set up new servers, and you have to take your external drives, your data storage, you have to bring those over from a different location, and yada yada yada. So it literally takes days to actually get back to business as usual, because it is absolutely the longest recovery time objective as well as the lowest cost, right? You don't have an actual facility that's replicating everything in real time. You don't have the facility that actually has the equipment, and you need to install the equipment and configure the equipment, so on and so forth. So the cold site, right, is going to take the longest amount of time to recover. So the recovery time objective for a cold site is days. The recovery time objective for a warm site is hours, and the recovery time objective of a hot site is minutes. And as a result, the hot site will have essentially a duplicate set of equipment that's already installed, already configured, and their data is being replicated in real time. Most likely, they're accessing their data from a cloud storage location, so that they don't even have to use external drives, physical drives that they would have to connect to those machines. They just pull the data from the cloud. A warm site probably uses external drives to store their data, and they can just transfer those external drives to whatever the secondary location is, and just make sure that they just plug those in so that they can access their data. And maybe they need to, update their software that's on these machines because it's been a couple of days or whatever that the software hasn't been updated, so on and so forth. So that can be done in a matter of hours. Cold site, literally, they don't even have the equipment that's installed. They need to go get the equipment, or they need to set up the equipment and then actually get the data from wherever the data is sitting, so on and so forth. So cold site is days, warm site is hours, and a hot site is minutes for the recovery time objective. So here are a couple of examples. So we have the scenario one, which is a high recovery point objective and recovery time objective requirements for critical systems. So the problem is a financial services company cannot tolerate more than 15 minutes of downtime or data loss. So what you would do is you would deploy a hot site with real-time data replication to meet tight recovery point objective and recovery time objective requirements. Scenario two is the warm site for medium-sized businesses. So an e-commerce company needs to recover operations within 4 hours after a disruption. That's their problem. So use a warm site with pre-configured servers and partial data backups to balance cost and recovery time. Now, for scenario three, it's the low-cost DR solution for archival systems. So the problem is that a research organization can tolerate downtime for up to 3 days for non-critical archival data. So you set up a cold site and schedule regular backups to keep those costs low. Scenario four would be optimizing the recovery point objective for database systems. And the problem is that a database application processes large volumes of data hourly, making frequent backups challenging. So you would then set the recovery point objective to 1 hour and use incremental backups to minimize data loss. And incremental backups could be another version of saying, we're just going to sync our backups, or we're going to back up in portions to make sure the most recently edited data or the most recently edited files or folders are the ones that actually get backed up. And that's the stuff that we're most worried about, because since the last backup an hour ago, only X, Y, and Z folder was the folders that actually were modified, or stuff was added to them. So we don't need to worry about the rest of the folders. We just need to worry about these 3 folders or these 12 folders or whatever it is that have actually been modified and things have been adjusted to them. And then you can move forward from there. And then scenario 5 is the recovery time objective versus the cost trade-off, right? So the problem is that a business must choose between a hot site and a warm site for its email system. And the solution would be to evaluate the importance of the email availability and select a warm site if some delay is acceptable. And then the cost could be either dollars and cents, or it could actually be the time, right? So the recovery time objective would be, okay, we can afford a day, right? Or we can afford 12 hours, right? A day would be like 24 hours. 12 hours would be half a day, so on and so forth. So what is that cost? The cost could be, oh, you know what, for us, it's really, really important to actually have our email because of whatever reason. So our recovery time objective only can be 5 hours, right? So it just depends on the business, depends on how critical that data is, how critical those services are. And that's how you would go ahead and calculate these. And obviously, as the network engineer or network analyst or security administrator, whatever your role ends up being, you are not the person to make these decisions. It's the C-suite executives, the stakeholders, the subject matter experts who will come in, and you have a whole meeting, like a conference, and everybody sits down and it's like, all right, so these are the reasons why we need to do this. These are the goals that we have for this. What are the options? And then you would weigh in with your opinions and your expertise, and then everybody else weighs in, and then the executives will be like, all right, so this is what we're going to do. And then that's when the decision is actually made. So you don't make these decisions. Your job is to just give your consult. Your job is to give your expert opinion on what you know, and then from there let them make the decision. Time for practice questions. So here we go. What does the recovery point objective measure, right? So the time required to restore operations after a disruption, that would be a recovery time objective. The maximum acceptable amount of data loss measured in time, that's the answer. The frequency of system updates, the maximum tolerable downtime for critical systems, and the answer is B right there. Which disaster recovery site type is fully operational with real-time data replication? That would be the hot site. A cloud site, which is a new answer that we have here. Obviously, we know what cold, warm, and hot are. A cloud site technically could be a hot site, right? Because if there is real-time data replication happening, that means that most likely we're doing it in the cloud. But there is no such thing as a cloud site. Technically, it's either a hot site, warm site, or a cold site. And in this particular case, the answer is hot site. What is the primary difference between recovery point objective and the recovery time objective? So RPO focuses on data backup frequency, while RTO focuses on recovery time. That's pretty much the answer. So I literally don't feel like, I feel like it's not even necessary to read the rest of this, because I really feel like that actually is the answer, and it is the answer. Which disaster recovery type has the lowest cost and longest recovery time, right? So cold site could be measured in days, right? Hot site is measured in minutes, warm site is measured in hours, cold site would be measured in days. There is no such thing as a hybrid site. Maybe there is, but in our education, our studies, there is no such thing. A company could refer to it as a hybrid site, but it doesn't exist in what we're studying. So lowest cost and longest recovery time would be the cold site. A company needs to ensure its email systems are operational within 4 hours of a disruption. Which DR site would be the most appropriate? And again, warm site measures in hours, hot site measures in minutes, cold site measures in days. The active site is absolute BS. It's irrelevant. So if it's in 4 hours, we could say that it's a warm site. Very good. Which of the following best describes an RTO, a recovery time objective of 2 hours, right? So backups must occur every 2 hours. That would be the recovery point objective. Operations must be restored within 2 hours after failure. That is the recovery time objective. Downtime of up to 2 hours is acceptable per month. That's not it. Data loss must not exceed 2 hours. That's not it either. So B. Very good. Which scenario would likely require a hot site for disaster recovery? So a university library system with daily usage patterns, maybe a financial institution that processes transactions in real time, definitely. Small business with archival data accessed infrequently, definitely not. Manufacturing company with RTOs, recovery time objectives, exceeding 48 hours, that's definitely not a hot site. So a hot site is what? Minutes, right? We need to be back up in minutes. So financial institution that processes transactions in real time, that would be it. What is the key advantage of a cold site? Cold site takes very, very long, but it's cheap, right? It's low cost to maintain. So immediate availability for operations, that's not it. That would be a hot site. Minimal operational cost, that's a cold site. Real-time data replication, that is a hot site. Automated failover capabilities, that's a hot site. So minimal operational loss. A company uses a recovery point objective of 1 hour for its database. What does this mean? The database must be backed up every hour to minimize data loss. I would say that's the answer. The database must be restored within an hour. That would be the recovery time objective. The system must achieve 1 hour of uptime each day. That is horrible, and that is not the answer. The database must remain operational for at least 1 hour daily, and that's also not the answer. So database must be backed up every hour to minimize data loss. Excellent. Which disaster recovery metric would dictate how frequently backups should be performed? So that is the recovery point. How frequently do we want to do backups? So it's our recovery point objective. I don't know what these things stand for. Oh, this is the mean time between failure and mean time to recover, I want to say. To restore, mean time to restore maybe. So recovery point objective is what we're talking about when it comes down to frequent backups. And that's it. That's all she wrote. So we can now move to network services and access. To get access to the Network Plus notes as well as the mock exams and the practice questions slides, join the Hackaholics Anonymous community. If you join as a cyber agent, cyber guardian, or cyber master, you'll get access to all of the notes, the mock exams, and practice question slides, as well as many other perks that are available to Hackaholics Anonymous members like Python automations and exclusive content, as well as monthly live streams with me. And to join, you can click the link in the description below, or you can go to our homepage and click the join button there, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now let's get back to the Network Plus training. For network services and access, the conversation is really around what services do we actually need and how can we access those services. And there are some critical services, for example, DNS, or the Dynamic Host Configuration Protocol. These services enable seamless communication within our network and access to our network. So DNS, for example, is about access, right? So if your domain names are not being resolved to the IP addresses, then people will not be able to access your website via the name. They'll have to actually access the website via the IP address, and then who remembers the IP address, right? Like nobody cares about that. So domain name services, the Dynamic Host Configuration Protocol, and SMTP if you're using email, or POP, Post Office Protocol, if you're using email. So these things are the services of the network. And then if you have data that's being accessed via network, so if you have a database or some kind of database or some kind of web application or something that's being accessed via a network connection, somebody actually needs to be able to get on the internet to be able to access it, then these also fall under network services. So you have a lot of different types of network services that enable the communication within your network and access to your business, all of that. And then the secure access methods. So this is when we talk about access. Secure access methods like Secure Shell, or the APIs, or a jump host, right? These things facilitate remote management and controlled access to those critical systems. So understanding these services and access methods is vital for managing and securing network operations. The first main segment we need to talk about is the IPv4, IPv6 services, and one of those key services is the domain name system, so DNS. DNS runs on port 53, if you remember from our section on ports and protocols, and it translates human-readable domain names, for example, example.com, into IP addresses. So this might be the IP address that accesses example.com, or this could be the IPv6 address to access example.com, right? So nobody is going to remember 192.168.1.1, right? Even if you're really, I'm sure if you're really good with numbers, you'll probably remember that. But then there are literally millions of websites. Probably for at the average human being, at the very least, there are dozens of websites that they use on a regular basis. So if you you have the personal websites that you access regularly, and then you have your business websites that you access regularly. So you have dozens of websites, right? And then for some people, it's like hundreds of websites. So who's going to remember hundreds of IP addresses? Even if you're really, really good with numbers, it's like it takes up so much bandwidth. It takes up storage in your brain, right? So getting a name is so much easier. Google.com, Facebook, Gmail, Twitter or X right now, ButcherBox or YouTube or fill in the blank, right? Think about whatever website you use, Crunchyroll, Steam, I don't know, you know what I'm saying? There are so many. I think off the top of my head, I can probably think about at least a dozen websites that I would use regularly, at least a dozen websites that I use regularly, depending on what I'm doing on a day-to-day basis. So this is where the DNS system comes in, and we don't think about it. We don't think about how important this freaking protocol or this service is, but it's so critical. So when you start thinking about, okay, I'm a network admin, right? I'm the guy who's supposed to manage this network, and as a part of that network, the website's name, the web application's domain is so important, and we need to make sure that our IP address actually resolves to this domain name. So the DNS system is very, very important. Now, the key features are these various records that we have, right? So we have the A record, which is the IPv4 address, so it maps the domain name to the IPv4 address. The quad A record, the quadruple A record, maps the maps the domain name to the IPv6 address. And then the MX record is for mail, so it specifies the mail servers for a domain. And the CNAME record maps one domain name to another. So for example, www.example.com or example.com, right? So you want to make sure that if somebody does the www, or if they don't do the www, it actually goes to example.com or wherever it needs to go to. It goes to the IPv4 address or the IPv6 address, right? So the name is very, very important. Then there's the recursive and iterative queries. So DNS servers resolve queries recursively, meaning they find the final answer, or iteratively by providing partial answers. So let's actually talk about this a little bit, because I think it's very important to kind of get a clear understanding of what recursive and iterative queries actually are. The recursive DNS query is when you ask a question and the server figures it out for you. So imagine you ask your local library, where's the book War and Peace located? And in a recursive query, the librarian would just say, go to fiction section, and they would actually find the exact shelf and tell you. So they would not just say, go to the fiction section, right? They would say, it's under fiction on, section A5 on shelf 4, whatever, right? So they'll tell you the exact shelf, the exact location. This is what recursive DNS query is like. So the process would be, your computer sends out a query to your local DNS server. Your local DNS server contacts other DNS servers like root servers or top-level domain servers, authoritative servers on your behalf. And then your local DNS server receives the IP address and then sends it to you. So it'll do all of the work for you, and then it'll respond and actually take you to whatever the website is that you're trying to access. So this is easier for the end user, for you, for your average customer, right? You don't have to chase down multiple servers yourself. it's faster for common lookup. So if the answer is cached in the local server, it's very, very quick. So everybody has a local DNS record, right? So on your computer, there's a cache of all of the DNS of the domain names that you regularly access. So if you want to go to Google, it's real quick, like it immediately pulls it up, right? There's literally no issue. It's a fraction of a second that it takes to actually look it up. Now, the drawback is that it can be exploited by attackers. So the DNS amplification attack is a version of this. It places more load on the local DNS server because it actually has to store those DNS caches. It actually has to store those domain names that have been resolved to specific IP addresses. Now, the iterative DNS query is you get hints and then you figure out it for yourself. So imagine asking the same question to the library, and then the librarian replies, go to the fiction section. Then you have to go to the fiction section and then find the book yourself. So you don't get a precise location, right? The process would be that the computer sends a query to the local DNS server. The local DNS server provides the address of the next DNS server. So instead of checking with all of the other servers, it'll say, this is the address of the next DNS server. And then you repeat this process until you reach the authoritative server for the domain, the server that actually holds the information for that domain and its IP address, so on. And then the authoritative server provides the IP address to you. So the benefits would be there's less load on your local DNS server, and it's more secure against some types of attacks, not against everything. The drawback is that it's more complex, obviously, for the end user, and it can be slower than recursive queries because it's not storing the DNS data inside of your local server, and it takes time to actually get access to the sites that you want to access. So recursive is the server does the heavy lifting, giving you the direct answer. Iterative is that you get clues and you have to do the work yourself. Now, something else that I think is really important for you to learn is also the concept of the various servers. So we have the root server. So think of them as the central directory for all TLDs, which is the top level domains, and a .com, .org, .net, .edu. These are the TLDs, right? So that's the top level domain. So the root server is the central directory for all of those top level domains. They don't store the IP addresses of the websites directly. Instead, they provide the addresses of the authoritative servers for each TLD, and then we'll talk about what that means. So the key point is that there are 13 root servers, and it goes from A to M, and it's distributed globally for redundancy, and they are crucial for the functioning of the entire DNS system. That's the root server. The TLD server, the top level domain server, these servers are responsible for a specific top level domain. So the root server controls all of the top level domains. The TLD server is specific for the .com or the .org. So there is a .com server, right, or servers that hold all of the .com addresses specifically, and then there are servers that hold all of the .org addresses specifically. So it's not everything in one location, it's specific to each top level domain. So they hold the information about authoritative servers for domains that have that specific TLD, so .com, for example. For example, the .com TLD server would know the location of the authoritative server for google.com. And then we get to the authoritative server, which is the final authority. These servers are specific to a particular domain, for example, Google or example.net. And the role is that they hold the actual IP address that is associated with the domain name and its subdomains. For example, google.com, mail.google.com, whatever, right? So when you type a domain name in the browser, your computer queries these servers to find the corresponding IP address, right? And the analogy is that imagine you're looking for a specific book in a large library. So we're going back to the book thing. So imagine you're looking for a specific book in a large library. The root server, which is the library's main directory, telling you which section, fiction, nonfiction, etc., to look in, right? So it's a .com or it's a .org, right? It's telling you which section to look in. So from there, you get to the TLD server, which is the section heading. So you actually get to the .com or the .org, right? So fiction or nonfiction, these are the actual section headings. And then the authoritative server is the specific shelf where the book itself is located, or the specific server where that google.com or facebook.com is actually located. So root servers are the starting point. TLD servers narrow the search down, and then authoritative servers provide the final answer, meaning where the actual IP address is being stored. So now that we understand this, now we can make more sense of this recursive and iterative queries that are available under the domain name system, meaning that the servers resolve queries either recursively, finding the actual final answer for you, or iteratively providing partial answers. And really, for the most part, the modern DNS systems actually combine these things together. And there aren't very many users that, really any users, I don't even have to go ahead and be like, hey, I've never visited, this one website, so let me go ahead and find the root server and then the TLD server and the authoritative server. I never had to do that. It's just that my computer does it for me. My system does it for me. And it'll take a little bit, and when we say a little bit longer, we're talking about an extra second or something like that, because this is still super fast, and at least in my specific location with the internet that I have. So it's very quick. But then when you actually have your recursive server, which is finding the final answer for you, that's the DNS server. It's inside of your DNS cache. Your computer and your web browser know what the IP address for Google is. So it just immediately goes to that IP address. It doesn't need to go on a hunt to try to find that IP address. It knows what that IP address is, and it just immediately goes to that. So that's what recursive is. Iterative is going through the root and then the TLD and then the authoritative servers and finally finding that IP address for you, and then it delivers it to you. But it happens so quickly that we barely even notice it. Like if you're in a decent location where you actually have decent internet and your computer is fairly quick, then that happens in a matter of a second or two. So that's really the big difference of it. So now use cases for the domain name system is that it resolves the domain names for web browsing, and at hosting services with custom domain names, that's what it actually does. So it hosts services with custom domain names. And it could be, again, like for example, the mail.google.com, that could be a version of it. So if it has a subdomain name, that could be something that is done with the DNS server as well, the DNS system. Another key service is the dynamic host configuration protocol. So DHCP dynamically assigns IP addresses and other network configuration settings like the subnet mask, the gateway, the DNS server, and it does it for any given device inside of a network. So it assigns IP addresses and other information, and this is more specific to the actual device, right? The actual devices that are inside of the network, not so much the web application or the website. The websites also need IP addresses, and those are done through DNS, but for the most part, DHCP only resolves the IP addresses, or it assigns IP addresses and other configurations to individual devices, and the DNS server technically is a device, right? So the gateway IP address, the subnet mask, all of these things are actually interacted with the DHCP protocol and then the given device that is on that network. So DHCP dynamically assigns IP addresses as long as you've done the initial configuration of saying, okay, this is our subnet that is available for all of our machines that come inside of this network, and then this is the gateway that we want, so on and so forth. So once you do that initial configuration, any other device that enters that network automatically, dynamically gets all of that stuff set up with the DHCP protocol. Sorry about the noise in the background. It's rush hour currently, and so people are driving through my block, and for whatever reason, people feel like they need to like speed or gas it like really crazy when they go down this block, which is, it's the most ridiculous thing. But anyways, sorry about that. Moving on. Hopefully you didn't even notice that, and I'm just saying something that you're like, what are you talking about? I didn't even notice it. But whatever. Anyways. So key features of the DHCP, the Dynamic Host Configuration Protocol. Lease time is the duration for which IP addresses are assigned. And this is actually a really big thing to understand. So if you go in a coffee shop, for example, and you are connecting to their Wi-Fi, there's an IP address that is assigned to your computer while you're in that coffee shop, right? And then let's say you never visit that coffee shop ever again. and or let's say you visited, 2 weeks from now or something like that. The lease time at a coffee shop is probably much less than the lease time at your home Wi-Fi, right? So when you go to the coffee shop, they get so much traffic and they're limited to the number of IP addresses that can exist on their subnet. So what happens is that the IP address that's been given to your machine has been assigned to your machine for a day. That's what your lease time is in the coffee shop. Or it's been assigned to your machine for 48 hours, whatever it is. And then after that time, when you go back and try to connect to that Wi-Fi, you're going to get a new IP address, and then you're going to have a lease time of 48 hours for that IP address, so on. So the duration for which your IP address is assigned to that machine, depending on what network you're connected to, that duration is the lease time. Now the scope is the defining of the IP address range for that subnet. So when we say what is the scope, in different contexts, it means different things. Specifically in the context of networking, the scope is the range of IP addresses, the range of devices. When you're looking at cybersecurity or pen testing, the scope could actually mean the range of IP addresses, but it could also mean, okay, this is the range of attacks that you can implement, right? So it could be the range of the techniques that you implement, or it could be the range of the devices, the subnets or the IP addresses inside of the subnet. That is typically what a scope covers. And if you go to a website, for example, HackerOne, which is a website for bug bounties, and then you'll click on any of the clients or any of the companies that say, okay, we want to hire people to attack our company, and we'll pay them if they find any bugs in our website. They'll give you a range of domain names that you can attack, and that will fall under the scope section. So the options, which provide additional settings like the default gateway and DNS servers, are also another key feature of the DHCP. So the default gateway, the DNS server that your device would connect to, and then you have the DHCP v6, which is similar to the original, but it's designed for IPv6 networks, and it supports stateless and stateful configurations. So use cases would be automatically assigning IPs to devices in large networks, managing IP address allocation in environments with frequently changing devices, for example, guest networks like a coffee shop, right? Now we can move on to the access method. So we talked about the services, and now we can talk about accessing various services. So Secure Shell. Secure Shell provides encrypted remote access to systems for management and file transfers. So Secure Copy, which is SCP, would be the file transfer mechanism that uses the Secure Shell tunnel. And Secure Shell typically resides on port 2022 or 20. It resides on port 22. And you can use a variety of different services through the Secure Shell tunnel, through the Secure Shell encryption. So the key features is that it uses public key cryptography for secure authentication, which means that it's asymmetric, meaning that there's a public key and a private key, and usually the way that you can make that connection to the SSH is through providing your username and password. And then it replaces insecure methods like Telnet, right? So Telnet can also give you remote access. You can also transfer files and manage systems through Telnet, but there is no encryption. It is decrypted, and pretty much if anybody's capturing your traffic or sniffing your traffic, they can see what commands you're running, they can see what username and password you used, and Telnet it's been outdated for a very long time. It's insecure. It's important to know what it is, and it's important to know what it does, but the most important part of it is that it's decrypted. There is no encryption that is provided via Telnet. So essentially anybody that is doing a man-in-the-middle attack or sniffing your traffic or just watching your interaction with the remote host, they can see all of the commands that you're inputting. They can see what files you're transferring. They can see the username and password that you entered. Telnet is not secure. So just keep that in mind. SSH is encrypted. It's secure. Telnet is not secure. Now, it supports tunneling, forwarding, and transferring files via the Secure Copy, SCP, or Secure File Transfer Protocol. And tunneling is basically you create a tunnel, literally it's like a logical tunnel or a digital tunnel, but you create a tunnel using the secure shell protocol. And then from there, you can then forward the connection, or you can forward the access to that tunnel to a different service, or you can transfer files through that tunnel, right? So you've connected to the system, or you have an availability to that system. You know what to do, you know what username and password you're using. So you can basically just do secure copy, and then you would essentially do SCP, and then you do the it could be in either way. So it's actually right here. So we have an example of this. So you do the SCP, and then you do file. So you would have to give the full path of the file. So let's say it's, /USR for user /admin /file.txt, right? That's the path of the file, for example. So you would do that, and then you would say that I'm transferring it to this person, right? So same thing right here. We have user at hostname, but we're just doing SSH to secure shell to it to actually connect to it. In this case, we're doing user at hostname, and then we're going to do this colon, and then we're going to give the path where we want to place this file. And it essentially could be any path that you want to place that file, because it'll end up on that user's host, on a user's account. This specific piece needs to be exactly the path to where the file is on your system. So this one is very, very important. Otherwise, you're going to get an error because it'll say the file doesn't exist or whatever. On this one, you could literally just do / and it'll just put it on their root drive, and then they can go find it themselves if it's not that important. Or you could just put it on the, again, / user / Dave / desktop, and then the name of the file, and then it'll just copy that file securely using the secure shell protocol, right? So you can administer remote servers securely from any location by using secure shell. You can transfer sensitive files between systems by using the secure shell protocol and using a tunnel through the SCP or SFTP, and then you can just transfer the file that way. So secure shell is a very, very powerful protocol. It's a very powerful tool. We use it a lot in penetration testing and various capture the flag exercises. And, I use TryHackMe very frequently, and they give you the option of using secure shell to connect to all of the attack boxes and to be able to run many of the exercises, because it's secure. It's literally encrypted, and you can do whatever you want. Obviously, it requires VPN connection, and that's one of the other elements of this. So for TryHackMe to be able to connect to their attack box or to connect to any of the victim machines, the target machines, you need to connect to the TryHackMe server via a VPN connection, because VPN is also an encrypted connection, and it ensures that you actually have permission to access the TryHackMe servers. So this would be another one of those things where it's like, apart from having the username and password, you need to also have some kind of a VPN connection where your IP address on your machine has permission to access that server that you're trying to get a secure shell connection to. So there's multiple layers of authentication that you would have to go through. And one of the key ones is you need to have an encrypted connection via VPN, and then you use secure shell to establish your actual connection to that server. So we can now move on to the next one. The API is becoming more and more important as we go along with the world of computing, especially with artificial intelligence. You can connect to the various AI tools through their API, and then you can then train that AI to interact with the API of another tool or of another website, and now you can combine their power to do a variety of really awesome things. And APIs it's just more and more important. So the best way that I can, I think it's like a good way to actually give you a visual for this. So let me find a really good visual for this. Okay, this is a pretty decent example. So the Uber app, right? So when you connect to the Uber app on your phone, there are several APIs that come into play to actually make Uber function. One of them is the Google Maps API. So Uber connects to the Google Maps API and then accesses Google Maps so that the GPS part of Uber can actually work. And then there's the other portion of it where there's the various APIs that it can connect to for payments, right? So an example here would be the Apple Pay API. So let's say you use Apple Pay to make all of your payments on Uber. So then it goes through the API of Apple for Apple Pay, and then it connects your Apple Pay wallet. And now you can use Apple Pay to make payments for whatever ride you have reserved for yourself. So at the very least, Uber uses the Google Maps API and the Apple Pay API. Think about your banking app, or think about Coinbase. Coinbase is another really good example. Let me see if I can find a visual for Coinbase. Okay, I can't find the specific image. For some reason, I feel like I may have seen it at some point somewhere. But so imagine Coinbase. I don't know if you've used Coinbase before, but it's a cryptocurrency trading application. And the way that you can put money into your Coinbase account, and this also applies to E-Trade or Webull or Charles Schwab's trading application. There are so many different financial service applications that go through the same exact process. And the idea is, right, you need to fund your Coinbase account or your E-Trade account. So the way that you would do that is that you would click on funding or add cash or whatever, and then it'll give you a list of different banks that you can automatically just connect to by using your username and password. And then it'll connect your online banking account to E-Trade, or it'll connect your online banking account to Coinbase. So let's say you click on the add cash, and then it gives you, Bank of America, Wells Fargo, Chase, Citigroup, whatever. And then so you click on any of those. And as you go through that process, you are literally connecting to the API of Citigroup, and then Citibank or whatever. And then you are now transferring money from your Citibank account to E-Trade or to Coinbase. So this is a really powerful concept when you really think about it. And APIs are just unbelievably useful. So the most basic version of it is when you connect to any application and it says allow location, right? Allow this app to access your location. That's like one of those things where it's like, oh, okay, so it's going to use some kind of a GPS. So it could be the Apple Maps or it could be Google Maps or something. And it's going to use some kind of GPS API to access my location. And then based on that, it's going to give me recommendations, customized recommendations for where I am locally, right? So there's so many different examples of this. I'm sure as you think about it a little bit more, you can think about what the potential examples are and how various APIs actually work. But any application that you use, at the very least, is using some kind of API to connect to your location, to connect a payment system that you have to the actual application so that you can make payments and you can make purchases, all of that stuff. So APIs are very, very powerful, and they're going to become even more powerful. And as an IT professional, I firmly believe that it is one of the most important skills that you will learn to develop, and you should definitely focus on learning how to use APIs, because you need to learn how to connect various applications together, and you may be doing it inside of the network for your company, or you may be doing it externally as you develop applications. So it's a big concept. I can talk about this for hours, but that's essentially what we're talking about right now when we're referring to the application programming interface, which is the API. APIs enable programmatic interactions with devices, systems, and services. So there is something called the RESTful API. So REST, which is the representational state transfer, and it uses HTTP methods like get, post, put, and delete. So you're making requests, right, against whatever the API is, and you would be making a get request, a post request, put request, delete, so on and so forth. There's a variety of different requests that you can make. But this is the RESTful API, where you can actually create representational state transfers, and you would do it, for example, using a language like Python, for example, or just using your actual URL or your web browser to make that API request. But for the most part, the ways that I've done it previously has been to do it through Python and then using a variety of different modules and libraries. For example, the requests library inside of Python to actually make GET requests against a certain API, which is the URL of a website, right? because these are HTTP methods that you're making. These are HTTP requests that you're making. So as it's HTTP, that means it's involving some kind of a URL endpoint for the API request that you're making. Then there's the return data in JSON or XML format, which is, again, something else that you can actually do as you make your RESTful API requests. And these, again, will be against whatever the URL is. But then now you want the data to be returned to you in either JSON format or XML format. And then you allow automation and integration of network tasks by being able to write code to do that, right? So you can actually integrate the API of Google's Gemini AI with whatever other security appliance, and then automate the interaction between those two things. And then you say, hey, Gemini, if you ever get some kind of a response from this security appliance that says there was this error or there was this alert that showed up, I want you to do X, Y, and Z, right? So it's so freaking powerful. There's an entire training series that's going to be coming up for interacting with APIs of AIs and how to integrate them between cybersecurity appliances. Because again, this channel is about cybersecurity and hacking. I just did this Network Plus training because I think it's very important for people to understand networking as they go across pen testing and ethical hacking and cybersecurity analysis, defensive security, so on. So it's very powerful. APIs are super powerful. I'm like nerding out about it. The use cases here are to automate configuration changes on devices. That could be something that you can do with an API. Collecting network performance metrics programmatically. That could be something that you can do with an API. So what an API allows you to do, among many other things, is to automate your interaction with something. And if you're good at learning Python, or if you're good at figuring things out and kind of learning as you go, then this will be one of the most powerful skills that you can teach yourself. So you will end up using this for a company that you work for, because there are going to be APIs that you can query using the HTTP methods and accessing these various API endpoints for the websites or the web applications. But then there's also automation and integration, my favorite word when it comes down to this concept. There's automation and integration that happens that you can do programmatically using a language like Python to actually make really freaking cool applications and integrations. And again, I'm just nerding out, but that's what an API is. It's an application programming interface, and it enables programmatic interactions with devices, systems, and services. And finally, we have the jump host that is under access. And a jump host is a secure intermediary system, so a middleman, right, that is used to access devices in isolated or restricted networks. So let's look at a visual of that. Super simple visual, but really powerful, and it helps us understand this. So we have the remote staff, right, the person that's trying to connect, and they're first SSH into the jump server. And so we have the SSH jump server, that's the intermediary, the middle device. And then that creates the SSH session with the destination or target server. So this person could have technically gone through or skipped this step and just done an SSH directly into the target server. But going through the jump server is most likely the situation that will end up happening, mostly for security reasons, and making sure that for whatever reason, if somebody is watching your session or they're trying to capture your session, they can't do it. Technically, a VPN server can actually be a jump server. Technically, if we wanted to think about it as just an intermediary, a VPN could actually be a jump server. But this is the visual of what it looks like. You have the person who's trying to connect. This is the endpoint. And then there's this intermediary, this middleman device that acts as the jump server. You jump from this server to this server. The jump host acts as a single entry point to the internal network. It implements strong access controls like multi-factor authentication, and it reduces the attack surface by limiting direct access to critical systems, right? So this is why we have the jump server. You first go through the jump server to be able to access that critical system, because if you connect it to the critical system, that reveals the critical system to whoever may be watching. And that just by itself could open up a can of worms. So instead of doing that, you go through the jump server first, and then it looks like you're just interacting with the jump server if anybody's watching your interaction, but technically the jump server has now connected to that critical system that you're trying to access. So what it looks like is I'm just communicating with the jump server, and if somebody's watching all of my interactions, it just looks like I'm communicating with the jump server, but the jump server is the one that's connecting to that critical system, and as a result, it's giving me access to that critical system. So the use case would be accessing production servers in a secure environment and auditing and logging access to sensitive systems. And all of these things are done through that jump host, which is the secure intermediary system that's used to access devices in isolated or restricted networks. All right, scenario time. So scenario 1 is resolving domain names with DNS. And the problem is that the users cannot access a website by the domain name. So we want to verify that the DNS server configuration, and then make sure that the correct A record, which is IPv4, or quad A, which is the IPv6, and making sure that those records actually exist, right? Scenario 2 would be automating IP address assignment with dynamic host configuration protocol. And this is the problem here, is that there's a large office that manually assigns its IP addresses, which leads to conflicts because, I don't know, lack of organization, or you don't realize which one you have assigned, whatever. So deploying DHCP to automate those IP allocations reduces the administrative overhead, and it makes sure that there are no conflicts, because DHCP is much better at keeping track of what has been assigned and what is available. Then we have the securing remote server access with Secure Shell, and the problem is that administrators need to remotely manage a Linux server. So we would use SSH for encrypted access and disable insecure methods like Telnet. Just disable it. Don't even have it be available. Nobody should be able to access Telnet. It should be disabled. That's part of network hardening and hardening your systems, is to just disable these things that are insecure and we're never going to use them. So let's just make sure that nobody can access them. Scenario 4 would be to automate tasks with APIs. And the problem is that a network admin wants to collect real-time traffic statistics from the router. So they would use a RESTful API that's provided by the router to programmatically gather metrics. So they would create a little Python script that queries these RESTful APIs. It makes requests for those APIs, and then from that, they pull the data that they need. And finally, we have scenario 5, which is restricting access with jump hosts. And the problem is that the company wants to limit access to production systems. So they would configure a jump host that requires multi-factor authentication, and then you would log all activities for compliance purposes, meaning all of the activities, all the connections to that jump host, and all of the connections from the jump host to those production systems for compliance, as well as incident response and security investigations, and whatever other reason you would need logs of all of the activities, right? To just make sure you keep people accountable, etc. Which brings us to our practice questions for network services and access. So let's jump into it. What DNS record type maps a domain name to IPv4? So A record is v4, quad A is v6, MX is for mail, and CNAME is to just make sure, you know, if they use example.com, it goes there. If it used www.example.com, it goes there. So for IPv4, it is A. What is the primary purpose of dynamic host configuration protocol in a network? To resolve domain names to IP addresses? That would be DNS. Dynamically assigning IP addresses and other network settings? That would be the answer. Encrypting remote access sessions? That would be Secure Shell. Providing secure access to isolated systems? That would be a jump host. So dynamically assigning IP addresses. Which protocol provides secure encrypted remote access to systems? That would be our friend Secure Shell. Telnet is not encrypted. We want to never use that ever. FTP is for file transfer protocol, and that is also not encrypted. So if you're going to use file transfer protocol, you would use SFTP, which is the secured version of it that uses SSH to encrypt your session. And HTTP is also not secure. It is also not encrypted. So the secure version of this would be HTTPS. So the only thing out of these options that is actually encrypted is Secure Shell. What is a key feature of a jump host? It dynamically allocates IP addresses to, that's DHCP. It serves as a secure entry point to access isolated systems. I mean, that's the answer. It replaces public DNS servers for local resolution. Replaces public DNS servers. I'm trying to figure out what that would be. It automates network configuration tasks. That is also not the case. So serves as a secure entry point. Very good. What does the quad A DNS record do? It specifies mail servers, that would be MX, maps a domain name to IPv6, that is the answer, maps one domain name to another, that is the C name, resolves IP addresses to domain names, that would be DNS. So IPv6 is the answer. Which method is commonly used to programmatically interact with network devices? So programmatically interact with network devices. DHCP is for assigning dynamic IP addresses. SNMP would be the simple network mapping protocol. So I think that would be the answer, actually. API is the application programming interface. And actually, no, technically, I think it would be API. So API would be the programmatically interacting with network devices. SSH tunnel is for encryption. I'm going to say it's API. Okay, very good. What is a common security measure for a jump host? To disable all logging features? That's not true. Enable telnet? No, you never want to use telnet. Requiring multi-factor authentication? That's pretty good. Assigning public IP addresses to all devices? No, that's not a good idea. So requiring multi-factor? Very good. What does the lease time in DHCP define? The frequency of DNS updates? No. The duration for which an IP address is assigned to a device? Yes. The maximum number of devices supported by the DHCP server? No. That would be more the subnet. And then the period before DNS records expire? Ooh, no, that's not it either. It's the duration for which IP addresses are assigned to a device. Excellent. What is an example of a RESTful API method? So trap is not it. SCP is secure copy. Tunnel is something that, I mean, it's not a method that we do, but it's something that is available through SSH, secure shell. So a method is referring to the type of request that can be made. So think about it like that. If you're doing RESTful API, you're making requests to a web server or a web application through HTTP. And post is when you send data to it. So it's a type of request that you can make. You make a post request and you send data. For example, a username and password. That could be a post request that's made. Very good. Which access method replaces insecure protocols like telnet? And that would be SSH, because it is the secure encrypted version that of telnet. FTP is not secure, it's unencrypted. HTTP is also unencrypted. DNS, I want to say that DNS is also unencrypted actually, but it's just a domain name system. So it really resolves IP addresses to domain names. I wonder if DNS is, I don't think DNS is even encrypted. I don't think like encryption even is considered as a part of it. I would assume that it would be encrypted to just make sure that no IP addresses within your internal network are revealed. But I mean, the answer to this is that it, SSH replaces telnet. But this would be interesting reading if you feel like doing some research for yourself. I almost want to do it right now, but I don't want to digress from where we're at because we know that the answer is SSH. But yeah, that would be interesting to learn. 4.1 core security concepts. So let's just real quick, let's just ask Google if DNS is an encrypted protocol. That might be interesting. Right, so see, DNS is not encrypted. So DNS domain name system is not inherently an encrypted protocol, meaning that by default, DNS queries and responses are sent in plain text and can be seen by anyone in the network, including your internet service provider, making it vulnerable to eavesdropping and manipulation. However, you can use encryption protocols like DNS over TLS, which is DOT, or DNS over HTTPS, which is DOH, to secure your DNS traffic. I felt like, honestly, I was like, I don't think this is encrypted. So just looking at the answers over here, the only thing that is encrypted in all of these answers is secure shell. All of these other ones are not encrypted. So that is good to know. Now, officially, we can move on to core security concepts. To get access to the Network Plus notes, as well as the mock exams and the practice question slides, join the Hackaholics Anonymous community. If you join as a cyber agent, cyber guardian, or cyber master, You'll get access to all of the notes, the mock exams, and practice question slides, as well as many other perks that are available to Hackaholics Anonymous members, like Python automations and exclusive content, as well as monthly live streams with me. And to join, you can click the link in the description below, or you can go to our homepage and click the join button there, or you can simply go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now let's get back to the Network Plus training.